Well, hey there. Hello. How are you? Welcome to SkyTour live stream for today, the 8th of December. And I do want to say I have a special welcome for Darrell Mason, who's with us. Hey, Darrell, how are you? Darrell's on mute.
Hello, Mark. I'm off mute. Sorry about that.
That's okay. How you doing, Darrell?
Thank you. I'm fine. How are you?
Just good. Hey, and I also want to welcome a special guest star who's joining us tonight, Izabela Melamed from Sofia, Bulgaria. Hi, Izabela. Welcome to SkyTour live stream. It's your first time here with us, live with us all. How you doing?
Hello, Mark. Thank you very much. I'm very excited to be here and to talk to both of you and to see both of you and the people in the chat and to see them from here.
Oh, yeah. That's good. So I wanted to say...
Izabela.
Yeah, say hello to Darrell, too.
Hey, Darrell.
Hi.
Hey, Darrell. It's very nice talking to you.
So you know what we want to say
Hey, guys.
is that Izabela has her own website that she's used and put together, and she does a lot of image processing of all of our imagery, and she's really darn good at it. And I just wanted to have her on because she deserves to be recognized for everything she's done, and that's what this is about. And in a little while, and Darrell, if I don't get to it right away, you can remind me too, but we do want to take a look at her site. And she'll tell me the link and we'll go to it, and then you can all get the link. I'll put the link actually in the description to make sure that you can get to it as well. But Izabela, I had a question for you, and that is,
Sure.
when did you use Photoshop, correct?
Right. Yeah.
Okay. When did you start doing processing of our images, and what prompted you to do that?
I started to do it I think less than a year ago. And what prompted me to do this, Mark, I blame you for this because I saw your images and I like them so much, and I started to learn about astronomy, about there are so many things that I actually saw for the first time, and nebulae and globular clusters and galaxies, and somehow this I was amazed. I was blown away with these images, and when I saw them process, I just thought that it's a magic, and I decided that I have to find out how to do this. You thought it's Photoshop, so I thought, okay, I can crop images in Photoshop, so maybe I can process images.
You've come a long way. You've come a long way from just cropping images in Photoshop to processing them to get the full extent of the data out. And so that's another reason. And for folks that don't understand, Photoshop, look, there's a satellite going through right there. Hey. For folks that don't understand Photoshop, it's just an image processing program that made by Adobe. Most people use it to do their holiday photos and commercial work. They don't use it to do astrophotography. That's in the minority, I would say. The majority of people use it for commercial graphics stuff, which, by the way, is something that is your specialty, isn't it, Izabela? You're also a commercial artist, aren't you?
I am animator, actually, artist animator, which is not exactly artist, and I do cartoons for living. And but I don't work so much in Photoshop because I work in 2D animation. This is cartoons like Family Guy and this kind of Simpsons.
So cell animation.
Cell animation was once.
Yeah, a
now
long time
it's
ago.
computer animation.
Right, it's all digital, yeah.
And I use programs like After Effects and Adobe Animate and this kind. Photoshop almost for nothing because it's raster. I don't know. Maybe I should explain what is raster and the other.
You mean raster versus vector graphics? It's a difference between two different types of graphics.
Yeah, two different types here. Correct. So the point is that I don't use Photoshop so much. I don't need it. It's for still images. It's not for moving images. For moving images, there are different programs which are much easier and
for the record,
easier
Photoshop,
for drawing.
Yeah, you're right. Easier for drawing. Photoshop is come a long way. It can actually edit videos, and you can actually do that kind of thing. Because keep in mind, Adobe Premiere, right, is a Adobe product which does video editing, and some of those filters in Premiere are also in Photoshop. So you can add, for instance, special filters to lots and lots of frames in a video all at once, in the same way you do in Premiere. But you're right, it's certainly not anything like a dedicated product that's just for that kind of animation. I use Cinema 4D, for instance, to do 3D rendered animations, and I've done them for television and other things. But it's pretty interesting, to use that. But it's so nice to have someone here who does that and who's actually taken our images and run with them. I just love what you've done.
Yeah, I'm kind of obsessed with them at the moment, but
well, that's okay. Hey, Darrell, I mean, you've seen what she does. I mean, do you have anything to add to this?
I think she does great work. Both the astrophotos and her animation. She's on YouTube also, people, if she cares to share the site or her channel.
Yeah, give me a minute.
Yeah, stick it in the chat. Go over to the chat and throw it in there, Izabela. And while you're doing that, I just want to say hello to Marianne Robb, who's here, and to Roni Hassan and PG and Donald Kunzer's here. Hey there, Donald, and Genghis and Rockstar. And we also, it's a kind of a fun night. We're going to have a fun night here tonight. And Susie Cat, how you doing? So we have a lot to zip on through and have some fun with. I don't know how much we'll get to, but we're going to do our best to get to as much of it as we can. Hi there, Carmen, Daisy, and Zoe. Amethyst, as always, you are diehards in here. And I'm actually going to do something. I just rewarded them for something they've done for us, for being part of that. Laurel Singleton, how you doing? Nice to see you. And Mike is here, Mike C. Yeah. And and Tim F is here, yep. I'm just going through the list, guys, and saying hello. I wanted to say something about Marianne Robb. She's here. Marianne Robb is vital to SkyTour Livestream West. She is like one of the linchpins, one of the key people in getting SkyTour Livestream West off the ground. So everything you see on this screen right here, you can thank Marianne Robb for facilitating a part of it, okay? So I have to say that. And I have to say hello to Bonnie, Anahata77. How are you? It's so very good to see you. I met Bonnie in person, and she is a wonderful human being. I was speaking in Colorado, and she drove hours to come to the talk. I can't believe... I guess people in Colorado drive hours. If you go to the store in Texas, maybe it's hours. I don't know. Okay, but she was incredible, and she came to dinner with us. I thought it'd be very nice if she came to dinner with us, and everybody agreed. And everybody wanted to see her come to dinner with us, and it was very nice meeting her and talking to her. Very, very interesting person. So if you get a chance to talk to Anahata77, don't turn away. She's got a really interesting story to tell, interesting capabilities and stuff that she does, so I'm glad to see you here. Hey Do, how are you? Do is also here, and I'm just moving the telescope randomly right now, but I'm just gonna find some stuff for us to look at here in just a moment. All right, well, there we go. That's everybody who's in here right now that has actually left a message. If you haven't left a message and you wonder why I haven't said anything, it's because you need to leave a message and to get a message. There's 21 people watching, and I didn't mention 21 names. So just join the chat, and we'll acknowledge you. And if you've got something you'd like to see, let us know. Izabela's joining us tonight because she has been one of our most ardent supporters, and she is. Oh, look, that's another satellite. Before we even came out, we saw like 3 satellites before this. The ISS almost went through. That said, why don't we check things out? If you guys are just joining us and haven't ever been here, let me show you how it works. Right there is the telescope in the building. Right, you see it right there. That's the telescope over my head. Right, up above. All right, this is the telescope control center right here. North, south, east, and west controls the direction the telescope moves. This is the telescope computer, which is right here, and I will occasionally be playing around in there. This is, of course, the main view. Ta-da! This is where it all happens. And then over here on this side, you're going to see this whole screen pull out. This is actually the camera control system right here. The camera we're using is a dedicated astronomy camera. It takes pictures unlike anything I've ever seen. It's a gorgeous camera. And our telescope is a telescope that is running at what's called f2. That's the focal ratio that we're running at. Now, you've heard of cameras that might be, running at f8 or f16 or f22. And that's really the size of the opening, right? So f22 is a little tiny opening. f8 is a bigger opening. f2 is a massive opening. All right, so this telescope is running 25 times faster than before we modified it to run at this speed. So when we see stars, we're seeing way more stars than we normally might see. Yeah, so it's pretty cool, and that we thank a company down in Tucson for that called Starizona. So Starizona is a wonderful place to visit if you ever get a chance. And tonight's stream is brought to you by Sky Through Livestream. No, that's us. That's Sky Through Livestream is me. Tonight's stream is brought to you by FX Models, which is my company. So I'm self-sponsoring tonight. And FX Models is a company where we make these amazing 3D printed models of the moon, craters, and so forth. And this is the last week you can order them before Christmas. So if they show is out of stock on the site, just email me at info@fxmodels.com, and the website's right there, fxmodels.com, right there. So if you check it out, you email me, I will get back to you right away and see if we can get you something for the Christmas time. End of this week will be pretty much the cutoff. After this week, it may or may not get there in time for Christmas. But we sell lots of 3D printed craters. We have a couple on our site now that are available right now. But if you have a favorite crater on the moon and you would like a favorite crater, all you have to do is let me know, and I can go get it, because I actually I have access to the entire curated data that is done by the U.S. Geological Survey, and I use that data, and so I'll make those craters for you. Right? I can grab and bring them down and prepare them. You're good, Darrell.
I'm sorry, that reminds me of something I've been thinking.
Yeah.
I saw a discussion elsewhere on the web in the last day or two about the cube on the backside of the moon that the Chinese rover found.
Yeah.
And people were wondering, gosh, can we see it from Earth into Hubble? All those usual kind of questions. And, well, no, we can't, which we've talked about before. The Hubble's not a good choice for looking at the moon.
Right.
But
right.
I had wondered, you were referring to the Lunar Reconnaissance Orbiter just now.
Yes.
And the name of the crater is Von Karman, I believe.
Mm-hmm.
If we had precise coordinates, if we could look at the LRO data and maybe see what all the fuss is about. You know what I mean?
Actually, I do actually, and I have a theory. Now, for those that don't know the story, the Chinese rover saw, and they showed a photograph of it, this object that looks really strange, and the press, of course, going off in the wrong direction, automatically saying, going over to this hut, or this house seen on the moon. They're putting the wrong impression in people's minds already, because we don't know what it is, and that's really just bad journalism. It's just trying to get clicks and readers. But what they saw was the strange squarish looking blocky structure. and they're heading over to it. Now, I can tell you right now, if it was really any kind of a structure, a real structure, we would have known about this. We would have known about this. This wouldn't have been something that's hidden, okay? We would have found out about this a long time ago. Why? Because the Lunar Reconnaissance Orbiter has covered every square inch of the moon to a fairly good degree. You can see down to 0.5 meter per pixel on that on the moon, in most places on the moon. You can zoom in and zoom in and zoom in. We'll do another stream about the Lunar Reconnaissance Orbiter Quick Map. That's QUICK Map, M-A-P. If you look that up, LRO Quick Map, you'll find this moon that you can zoom in endlessly to, apparently. And we can also go to specific places, as Darrell just told you, and check this out. And hey, we'll do it. We'll check it out and see what's there. But I think that it's so small that it would be within that 0.5 meter per pixel range. You might not see it. It might just be a ever so small pixelation. But I think it's worth looking at. But keep in mind, right next to this thing is a crater. And usually what these meteors would do when they strike the moon is they would gouge out a chunk of the moon. They'd get vaporized, these meteors. But they would gouge out massive blocks, all right, and lay them over the edge of the crater. And that happens on Mars. That happens on other moons and planets in our solar system. And it happens on the moon. So we see blocks like this. And because there's no erosion on the moon, there's no reason why a sharp-edged block that's literally sliced off or fractures along one of its crystal lines inside, there's no reason that it would ever erode. It would stay crisp and clean for billions of years. So there's that possibility too. But I can't wait to see it. I can't wait to see.
I just wondered about that. That might make an interesting project.
Yeah.
I don't go to the LRO site very much, and I've frankly forgotten everything I did know about it. But I know the name of the crater. I don't know how big the crater is, but it seemed like it'd be an interesting way to waste some time at least, Wouldn't it be interesting if we saw a paper on its front doorstep?
Or a dog tied to a leash.
Right.
With a helmet on.
Out of the chimney.
Right, exactly. Well, folks, I'm going to take us to an object here to check it out. We actually, the sky right now, it's a little bit bright because we're kind of near where the moon is. But let's take a look at what the moon looks like here first. And I think we're approaching. This is how big the moon is in our field of view. I guess we can go check it out. What do you think, Darrell?
Sure.
Yeah. Let me see if we can. 23 degrees. I may have to steer to it because that's below the level. We'll be partially into the roof line of the observatory. So let's go. Let's tell it to go to Jupiter first, and you'll see how big Jupiter will be in this telescope. It's actually pretty small. You'll see the telescope moving over my head now, and then you'll see over here. All right, the telescope is going to head to a star. All right, and that's going to use. We might have. I see we have clouds too.
Uh-oh.
Yeah, no, that's okay. I saw that we're going to have some clouds. And they're bright because of the moon. Okay, and now this is a star, I think, that we're centering on. No, that's Jupiter, I think we're centering on.
Yep, there's the...
Yeah, I see it.
Galilean moon star, the side of it.
Yeah. No, I haven't focused yet. Let me do one thing while we're here. I did see that there's some clouds, these guys, and I think we're getting a little bit. We're way over here. So let me just do one acquisition of one. This will be a 10-second integration. We're going to take an all sky cam. This is a 180-degree view. This is the east toward Phoenix. This is the west. This is the south, and north is at the bottom. Okay, so that's what's wrong. We got just a couple clouds that are filtering through. Here's the Milky Way, right here. Okay, so this will be okay in just a few minutes. We just have to wait it out. All right, and you can see Jupiter right near the moon. It's actually pretty bright over there, so that's why we're seeing that like that. But while we're waiting, we'll just check it out.
While we're waiting, would you like to do that little stellarium thing real quick?
Yes, I do, actually. That's where I was going to go next. I just want to move the Jupiter up into the view here. Get it right here. And then, Darrell, as you know, every Sunday on Sky 2 Radio, Darrell will sit and tell you all about the things in the sky. Well, we're doing that tonight, too, with stellarium. So what I'll do is I'm going to bring up stellarium here and allow Darrell to tell us all about it. So here, for now, while we're waiting for the clouds to clear, we'll do this. All right, so here is our stellarium view, and this is our moon. All right, but I think Darrell wants to point something out here. So why don't you take it away, Darrell? I'll do what you tell me to do here, so people can see.
Okay. We're two people doing this tonight, folks, so bear with us. Mark, can you go back to about 6 p.m. or a little before 6?
Yeah, we'll do that right now.
Okay, if you look up in the southwestern sky, that's good right there.
Okay.
The last 2 nights, 2 nights ago, the moon was directly under Venus. Last night, the moon was directly under Saturn. Tonight, the moon is directly under Jupiter. And it is just really beautiful out to get a look at. Now, Venus is set already for tonight. Venus is setting earlier and earlier because it's moving toward its rendezvous with the sun early next year. But right now, if you go out after sunset and look tomorrow night or tonight, Venus will be gone. But tomorrow night, you'll see Venus, Saturn, and Jupiter all in a row. Venus is the brightest one, lowest in the southwest. To its upper left will be Saturn, which is the dimmest one. And to the upper right of that, upper left, is Jupiter. And they're evenly spaced in the sky right now, and it's really making for a pretty view. Yeah. And the moon the last couple of nights has been sliding up under each of them by turn and just making an even prettier view.
Yeah, this is the 6th, the 7th, and the 8th.
Yep.
At the same time every night.
By tomorrow, the moon will have slid over to the left of Jupiter. So it'll make a string of 4 pearls, you see.
That's
I
right.
actually saw them today.
Did you?
Yeah, here in Bulgaria I saw them.
Wow, that's fantastic.
It was beautiful.
Yeah, I was out watching after sunset, checking my mailbox, and there it was, just right there. It was just pretty as sight as could be.
Wow, that's beautiful. And we're going to be covering upcoming Comet Leonard as well, and we'll be looking for Comet Leonard when we can, when it becomes an evening object. Okay, that's middle of December onward, and we'll try and find that for you. Also, this weekend, if Saturday is clear, we are going to track an asteroid, and we'll be able to watch it move in the sky. It's a near-Earth asteroid. It's whipping by us at a fairly high rate of speed, and we'll be able to check it and see its movement. So I think that'll be kind of fun to watch.
That would be great.
Yeah, and that's up in the northern part of the sky. So we'll have all that information for you. If it's going to be clear out there Saturday, we're going to be there, and we're going to be watching for it, okay? So hopefully you'll be there. So that's good stuff. So Darrell, you got any more that you want to add to this?
No, that should do for now.
All right.
I can say, as Mark alluded to, Comet Leonard, Comet Leonard is going to pop up under Venus on the 14th of December, and then he's going to fly a little higher and to the upper left every night. He'll be directly under Venus on the 17th, and That's also when the comet's roughly closest to us, so we see it moving the fastest in the sky.
Okay.
And that's something to look forward to next week.
Indeed. That'll be great.
That's it.
Well, thanks, Darrell. That was wonderful. Thank you for that little journey, that tour.
Sure.
And we will be happy to check back in and look for that comet in the middle of the month here.
Oh, yeah.
Yeah.
Maria and the comet should be cool to see.
Yes. Hopefully we can do that. All right. So when we talk about why it's looking so bright right now, that's because, again, it's a dedicated astronomy camera. It's very, very fast. But over here, if you look over here, you see the exposure time there. It says 1,000 milliseconds. That's 1 second, okay? And then the most important value right here, this is called the gain. This is sort of like the ISO, or the speed of the camera. And 327 means several tens of thousands of ISO. It's a very, very fast camera. And it doesn't have a lot of noise in the image. And that's what's important here. We can get rid of some of the noise. So those two functions are important. So what I'm going to do, pull myself way back down here again. What I'm going to do is I'm going to change our exposure time to about 10 milliseconds. Okay, a tenth of a second here. All right, and when I hit enter, the screen will be a little bit darker. Okay, and you can see Jupiter, and the clouds are kind of not really seen there, but you can see Jupiter with its moons, and you can see that Jupiter's kind of small here. All right, I'm also going to drop the gain down. So if I drop the gain down, then we'll get to the point where Jupiter is going to start to be the only thing we can see here. And if we zoom in on this part right here on Jupiter, then that's going to allow us to see a little better what we're looking at. But again, this telescope is not designed for the planets. This telescope is designed for the deep sky world, and we're not able to see too much planet-wise, and that's the issue here.
See
but
the
you
moons?
can see, yeah, we can see a little bit, yeah. All right, and you can see they're kind of bobbling a little bit because of the clouds, so it's kind of hard to figure it out with the moons, But let me just try and go down to like half that. Let's go to 5 milliseconds.
Give me just a second. I'll tell you which moon is which.
All right.
I have to look it up as usual.
That's all right.
When the sky clears up, if we stick around that long, 3 moons are visible right now, 2 on the left and 1 on the right.
Yeah.
From left to right, they're Callisto, Io, and then to the right of Jupiter is Ganymede. So Europa is hiding right now, probably behind the planet.
Okay. Yeah, I am zooming in more, but again, this particular scope, and I can see that our focus is off just a little bit. You can start to see some of the cloud bands here, but we have to do more focus. We'll get more focus on this when we get ready to do our deep sky stuff tonight. That's cool. We're looking at, we're at 312%. We're over 212% over 100% size. So that's pretty big. And you can see it dancing around because of the sky being so difficult. What's the sky like in Sofia right now, Izabela?
Let me look.
It's about 5 o'clock.
Well, it's cloudy because it was raining here 3 days, but they cleared and I saw the lining up of the planets and the moon.
Huh? That's good.
But right now it's cloudy. Usually it's cloudy.
There's the 3
Okay.
moons.
Yeah, you can see them.
Callisto, Io, and Ganymede.
Right, Callisto, Io, and Ganymede. Pretty cool. This round donut, this is an artifact of the lens system with bright stars or planets. We have that here. That's an unfortunate problem that we have. I say problem, it's built into some of these systems, and you do your best to eliminate it, and when we look at nebulae, we don't see it. But let's try something while we're here. Let's pull out of this just a bit. I'm going to, there's the moon down there. What I want to do is I want to center us up on Jupiter. And to do that, I'm going to make us move at just... hey there, Hunter. My youngest just got home from work. Okay, I'm going to move this down a little bit. And once it's centered, I'm going to go check to see how the telescope program is aligned to the actual view in the sky. So that's where that's centered, and so if I come over here now, the crosshair should be really close, and it's not quite close, so what we'll do is we'll do the final alignment right here, and then kaboom, it goes and centers on there, and now this program is now aligned to what the telescope thinks is going on. It's great. Alright, so I'm now going to head us down to check out the moon, but I'm going to manually drive us to the moon because the moon is at 22 degrees, and we're going to be looking at part of the building, and I don't want to risk the telescope not knowing where it is, and then that takes time to get it reset sometimes. We are adding a lifting column to this telescope, which is going to lift it another 20 inches hydraulically. So after the roof is open, the telescope's going to lift itself up into the air and with accuracy and be able to actually see much better. So I think that's pretty cool. Hey, Bonnie says that it's great to hear your voice, Izabela. See that? In the chat, she said hello to you, and it's beautiful to hear your voice.
I was wondering where you are, and I'm happy to see you back on the stream.
Yeah, we were wondering. She's doing great. Okay, so here we go. Let's change our speed now to just a little faster. This will be 0.5 degree per second, and now we're going to go south a little bit. And the screen's going to get brighter and brighter and brighter over there on the left. That little sliver of the screen that we're seeing, because we're going to get the moon in here soon. And it's going to be covered with clouds. There we go. So let's do this now. Let's head to the west. Here it comes. I guess we're going to see it now soon. Like maybe right now. Here's an interesting thing. Okay, here we are looking at the moon, but this part of the moon that you're seeing, this is not the side that's lit, of course, that is. But we're seeing the other side of the moon, and the reason we are is not for any other reason than the fact that the Earth is a bright blue light that's reflecting on it. This is called Earth shine. So that's what we're seeing. If we were to drop the level down, I have the gain set to 0 right now. All right, so that's called, zero gain. That means that we're just, looking at not even using the camera for its capabilities. I'm going to go to 1 millisecond though, and we'll move up from there. But look at that. So there's our moon. That's the way that looks now at 0 gain, and we'd actually have to go even lower to be able to see that. So like I said, this telescope is designed for faint deep sky objects. It's not designed for the moon and things like that. But we can see the moon, as you can see, and we're zoomed in now to 50%, and I can see that we need to focus a little more, and I do have a way to do that. We have a focusing controller system. We have tens of thousands of focusing steps that we can utilize, and right now we're at 518. Over here you see 48,518. And if I go to 48,418, for instance, say go to, you'll watch the moon's focus change a little bit. That might have somewhat improved it, Darrell. I'm not sure.
Yeah,
but
it's not a bad looking moon.
No, we have to do it on, again, for this system, it's not bad. What we have to do is we actually have to focus on a star, you know. But there's our moon. And now what I like to do actually, and I'm going to go back to 518 for now, and I will come back to 418 as necessary. That might actually be just a hair better. But, so what we're going to do now, hey there Amal, Amal's here, and Lynch Hub is here. What's going on, man? Good to see you. Long time no see indeed. Okay, so it's not quite the right focus. But what we're going to do is go back to show you the Earth shine again. And that'll be at 1 second. Nice thing is the camera can't be hurt by the brightness. Marianne Robb is saying, Izabela, I think you need to describe what we are seeing in your language. That would be so fun. Oh, she wants you to talk Bulgarian.
Marianne, when you say something, I obey. You told me to come here to the stream, I obey. So I don't dare to say no, but next time. Okay.
You see that?
Marianne,
Great having you on board.
thank you, Marianne, for everything. I appreciate you very much.
Oh, that's very kind.
It's great having you on board, Izabela.
Thank you,
It is.
Darrell.
It
I love
is.
it here.
Can I
No,
say,
we-
Mark, when
yeah.
we see the Earth shine there,
Yes.
if you go out and look at a young crescent moon, you can see the Earth shine if you
Yes.
have good weather. And the skinnier the crescent moon is, actually the brighter the Earth shine will be.
That's right.
Imagine if you were standing on the moon right now looking up at Earth in the sky, the Earth would be lit exactly the opposite that the moon is.
Mm-hmm.
And this is always the case. Where we see a crescent moon, on the moon you would see an oblate Earth. The crescent will be bigger tomorrow night, so the Earth from the moon will be skinnier tomorrow night.
So you take a look at the dark shadow of the moon, and that's precisely what the Earth would look like from the moon. That's how much your moon the Earth would be illuminated.
Yes.
It'd be like a waxing gibbous Earth compared to a waning, or maybe waning gibbous, waxing gibbous.
The Earth would be waning gibbous.
Yes, waning gibbous, and this would be waxing crescent. So it's sort of like a complementary phase. The Earth has phases as seen from the moon. That's the interesting thing that people would want to know.
And if you were on the moon looking up at the Earth in the sky, the Earth would be 4 times bigger across in the sky than the moon is. Because
Well,
it's 4 times the size of the moon.
and that's an interesting concept to utilize, because if we take a look at our view here, when we come out, all right, first of all, if you notice, this is the size of our field, right? We get 4 full moons across. So 4 of these moons would fit right across this field of view, all right? That's what we have for a field of view. And we have 3 full moons tall. Here's what's interesting about this. What Darrell just said, if the Earth was put in here, and we're looking at the Earth dead center on the sphere of the Earth as seen from the moon with this telescope, it would fill this whole frame. Because
Just be touching on the edges,
Yep,
we'd be
and the
losing
corners
it
would
off
be-
the top and the bottom.
that's right, and the corners might have a little touch of the edge, but not much. We'd just be filling it up. So that's how much bigger the moon would look from the moon. The Earth would look from the moon. Yep. Cypher 2, CND boy, how you guys doing? Thank you for dropping by. So anyway, you can see stars. That's very interesting. There's a star right next to the moon. There's a star right next to the moon. When it's full, we can do this and still see stars next to the moon, although it's harder. Depends where it is in the sky. But the moon is bright, it's not the astronomer's delight. It's the astronomer's blight. And I wish it would go away.
Astronomer.
Yeah, that's true. That's true. In studying,
special looking at the moon.
That's right. In studying planetary science, okay, I'm expected to know an awful lot about where the moon came from, how it was formed, and the mineralogy of the moon and all that. That's kind of goes without saying. So I can't slight it too bad, right? Because I'm gonna really have to buckle down and learn an awful lot about it that I may not know yet. But that's okay. All astronomy has its specialties. I'm just picking a new one. Yeah, there's Cypher. Hey, man. So, yeah. Donald is only being funny. Donald Kunzer. Yes, no. Actually, I saw a total eclipse with a flat Earth, and it's just a dark line across the center of the moon. Which I thought was funny. Okay, let's go look at something for fun here. And we will be getting out of the way here. I think of the clouds. I think we're clear of the clouds right now. I see Neptune's up, but the trouble is with the moon so near that Neptune's going to get washed out. We're not going to be able to see the blue of Neptune too well, unfortunately. So let's just go up. Now we are using a special filter to be able to see all kinds of wonderful objects in our telescope, so we'll be using that as well. Alright, let's see here. Daisy and Zoe ask an interesting question. If we were viewing from the moon, would we see North America or Asia? Whatever you can see on the moon, you may. Okay.
Daisy and Zoe, imagine you were standing outside looking at the moon right now. Well, if you can see the moon can see you. So you'd see North America and South America. That makes sense?
Whatever you can see, if you can see, as Darrell says, if you can see the moon, then it can see you. And that will be visible to you from the opposite side. So that's true. I think that makes sense.
Kind of makes how it works.
Yeah.
And for that matter, Jupiter could see you too. So could Saturn.
That's right. If you could get there.
Yeah. There's Aries right there, Hamal and Sheraton.
Yep.
And Uranus.
Yep. We tried looking at Uranus the other night, guys. It wasn't too impressive because, again, we could not really see its color too well, which was no good. I wanted to see color.
We did see the moons going around it.
Yeah, we had moons. Yep.
Like several moons. Now we're up past Taurus, and we're into there's Capella right now, the goat star. See the three little stars in the triangle right next to it?
Yeah.
Could see it better a moment ago. Those are called the kids.
Yeah, Capella and the kids. I'm gonna try this just to see what our night looks like. Okay, we're gonna try this. You're familiar with well, actually.
In Perseus now.
Yeah, I actually want to look at the California Nebula.
This ought to be good.
Yeah, even with the moon, it should look good. So watch the telescope up there. It's going to start moving. And we're going to lose the moon. And I'm going to come back in. It's going to dig up some star to use as a star hopping star, where it's going to then go to the next location. And I'm going to take the gain and pump it up to about 350. And that's where I usually go with this gain, and then I'll show you what we do. Okay, this particular setting right now, we have it's sort of like a high resolution low light finder that I'm using, a finder setting that I can set automatically. I can take it off right here, right, or I can put it on like so, and that's our star that we're using, and from there it's going to go to this nebula. Now as it goes to the nebula, you'll watch it, you'll see the nebula come in. There it is, in color. Isn't that incredible? That's called the California Nebula.
Ta-da.
Really, really cool. Yeah, it's beautiful.
This
All
works
right.
for a stack.
It's also huge, isn't it?
Oh, it is, Izabela. It's very big. I have to reposition this again.
California Nebula is up in Perseus, the hero.
Yep.
Almost in Taurus.
Yep. Okay. All right. All right, so now what we do is we move this telescope. I'm going to move it in slow increments. Okay. And I want to do it because if we don't, oh, I got to move this down now, I think. Yeah. Okay. Sometimes I lose my setup. It just goes wonky, and it did that a little while ago. Here we go. Okay. So I want to make sure I've got my speed set right. Yeah, I do. And now, this object you're seeing right here, this guy is going to blow you away. I mean, it's going to blow you away. So first things first, we're going to move the telescope over a little bit more to get more of it in the view. All right, and we are on a 1 second exposure, okay, so you can see it, and so it's like this. If I set it to like a few milliseconds, it would be instant. You would see fluid motion, but you wouldn't see what we're looking at. You wouldn't see our targets. This is how we do the compromise between seeing our targets and not seeing our targets. Okay, now, so this is the object we're seeking right here, and I'm going to move it over a little bit more. All right. So it's one thing to take a picture. All right. So let's just do that. As I sit here, the first thing that we do is we check to see what the focus is. So I'm going to go to 100% and see what our focus looks like. Okay. And I can see that it's not really quite focused because the stars are tiny donuts, almost hard to tell. All right. But I'm going to go in now, and I'm going to get in our focus system. And I'm going to make an adjustment. We're at 518. I'm going to go to 418 to see if it gets better. What that does is that rotates the focuser in little tiny increments. So here we go. Okay. It looks like 418 got us pretty close. And I'll zoom out now and see. Let's just minimize this. These settings are not accidental. These are settings that we found work. Okay, so let's go out to now an auto size. All right. Okay, so ready for this? Let's now do a photo. So this is going to be a 20-second photo. I'll say 25 seconds. And we're going to take off the finder mode because that'll affect what we're taking a picture of. And now I'm going to go into live stack. This is another feature. This is a feature that shows us the the fact that the images are being stacked on top of each other. Okay, and we're gonna have one get stacked on top, and I'm gonna clear the stack that's in there now.
Did you reset your gain, Mark?
Yeah, the gain is at 353. Look at that.
Nice.
And you look at the color in the background and say, well, why is it blue? It shouldn't be blue. You're right. So what we can do is we can do a color adjustment, a color correction, like that. And that really brings out the color. See that, Izabela? That's how, she's sort of seeing it from behind the scenes now with all of us. So that's kind of cool.
Yeah, it's very interesting. From the kitchen.
Yeah, from the kitchen. Yeah, it's from our kitchen, right? I mean, we're cooking up these images, So this.
I knew that you paint them.
Yeah.
In my kitchen.
Yeah. Well, I'm actually in my office. I think I might have told you guys this before, but if we look behind me here, okay, that's the SkyTour Livestream East telescope setup with its 2 telescopes. And it's in here in my office because we're refurbishing this telescope in preparation to put it into the new building, because we outgrew the actual dome that we had. I actually sold it to somebody down in Long Island, New York, because it just we ran out of room in there. I needed more room. Needed more space, needed more opening. So that's what we're doing now. Okay. All right, so right now we're stacking. We've stacked 4 images, by the way, as we've been talking. And what I'll do is I'm gonna do a little processing to drop the brightness just a bit to increase our black level. Look at that now, in an instant. And now what we'll do is, isn't that beautiful, Izabela?
It's incredible.
Look at that, and we'll even make it even bigger.
The color is amazing.
Cosmic fire. It's beautiful. Yeah, and that's actually the color of this thing too, which is kind of cool. I just like the California Nebula. This, and the actual place that I went is this little guy right here. This is actually a dark nebula that has been identified and has been cataloged, and so we went to this dark nebula. It's an LDN nebula.
Is it? Didn't know that.
Yeah, I'll show you. It's LDN 1469.
Is it part from the California Nebula, or it's somewhere between us and the nebula?
It's probably in the California Nebula, and that's a really good question. Because is what Izabela is pointing out is that every time we look at the universe, we see it in 3D. So when we're looking at this object right here, which I'll zoom in, we've stacked a few so it'll support zooming in a little bit. If you see noise in the image, like this color modeling that you see here, this modeling, this gets averaged out over time. And when the moon is out, there's more of it, just so you know. But look at the beautiful, beautiful structures here. This is beautiful. I'll say that since going out there and fixing this telescope and getting the lenses aligned properly, it's really come a long way. I could probably do even more focus adjustments on this. I mean tonight, just to focus more. But look at that. That is just stunning. Wow.
That's a lot of hydrogen too.
That's correct. Hydrogen 2 as in H2 as in ionized hydrogen. The way that works is simple. Hydrogen has a proton and an electron. And that hydrogen atom is a proton electron with an electron zipping around in like a cloud. It's everywhere at once. That's from something called the Heisenberg uncertainty principle. The electrons are more like a cloud around the nucleus. Well, the thing is, if there is some kind of ultraviolet light source nearby, like a bright hot star, that electron will go zipping off the atom. Now it's just a proton. Okay? But when that electron comes back collides with stuff out there, and it comes back toward the atom. Positive and negative, okay, positive proton, negative electron, they attract each other. And so the electron goes down into the atom and loses successive amounts of energy as it drops in. And it drops to a specific level where it gives off this color light that you see. This is called the n equals 2 level, as in number, n equals 2, number 2. Okay, that's part of what's called the Balmer series, in case you want to know, in hydrogen. And that gives off a characteristic red light, which is 656.28, I think, nanometers. And so it's actually quite a beautiful glow. It's the color of the universe. It's one of the main colors. The other color is blue, for reasons that Darrell knows, and that we talk about often. And there's no blue nebula in here. But what's interesting is nebulae like this that we see here. Keep in mind the field of our telescope is 2 degrees across. Okay, 2 degrees. That means that's 4 full moons across. And even so, with the moon out, we still have this beautiful nebula available to us because of the filters that we're using. The filters we're using will isolate hydrogen alpha, it'll isolate oxygen 3, and will isolate sulfur, and put all those through. And why those 3? Because those 3 are the primary components that we see in nebulae and galaxies. So that's why we don't see moon glow in here. We see some, but it's not that bad. We can get rid of it with a color correction. And we've stacked 16. Yep.
I'm sorry. I saw a really good astrophoto of the Flaming Star Nebula a couple of nights ago. Thought about sending it to you. An astrophotographer at one of the forums I go to took it. He took it in the Hubble palette, and it just changed the whole look of the nebula completely.
Yeah.
I prefer the regular, red, green, blue, whatever you want to call it.
Well, the actual color palette.
Yes.
Yeah.
True color.
True color. Yeah.
Hydrogen is supposed to be red, darn it, not blue. And who cares
That's
what
all right.
sulfur does?
Yeah.
Well, that's okay.
I
get
agree,
you.
Darrell.
See, two against one in a sense. I mean, I don't mind the Hubble palette, but again, the Hubble palette is designed for a specific thing, and that's to actually differentiate details that are otherwise hard to see. It's not as pretty, but it is much more able to be used for analysis. So, that's pretty cool,
To me, it's very misleading because the blue looks like blue sky, and somehow it's confusing, especially in the beginning when I started processing.
Yeah.
It looked like sky, and I couldn't figure out what is this until I found out that.
We talked recently about what can people expect to see when if the Webb telescope comes online.
Right.
Because it works in the infrared instead of visible, that they have to assign colors for an infrared image, and when you look at an infrared, when you see something in the infrared, how could you say what color it's supposed to be, because it's outside the visible spectrum. So to make it relatable to people, they pick colors and assign different wavelengths, how hot the different portions of the spectrum are in the picture.
Yeah. Now this is a region that's also pretty hot. This will show up in the infrared. The reason is because the hydrogen is glowing because it's been heated, and to a temperature where the electrons can absorb the and where the electrons will absorb the ultraviolet energy from a nearby star that's powering this nebula and leave the atom. So that glow also translates to temperature as well, because you know how it is when you stand under a hot sun on a beach, you feel that force of that energy striking your face. What's striking your face in addition is ultraviolet light, which is what gives you the suntan. The heat you feel, however, that comes from heated air, heated sand, and your skin itself absorbing the ultraviolet light and radiating away as heat, which heats you up. So it's really all about ultraviolet. And so the ultraviolet causes a tremendous increase in the temperature. And that's what ionizes these nebulae like this.
I wonder if the bright star toward the bottom is what's enlightening, is what's illuminating and exciting
this guy.
The nebula.
Yeah, I'd have to look in the SEDS database to see where that star is and see if that's in this proximity. If it is, then it's very possible. It depends what kind of star it is too. If it's like if it's a giant star of some kind, then it's very likely that can be the case. If it's not a giant and it's close to us, it won't be the star doing it. Literally, the stars that can be doing all this could be like a star like this one up here. It doesn't have to be. Yeah, it doesn't have to be a star like this one. Yeah, but it could be more than one source too. It could be these two stars. It could be this star here. But it appears like there's several broad bands that have been caused to be excited into that state, and if this does seem to be the star that would do it. The other thing to keep in mind is if it was this star here, right? These are powerful stellar winds. We've talked about this before. When these stars, put out their their hot stellar winds, they tend to create a cavity. They build a cavity around themselves of space that's empty of stuff, and that's kind of what we see here, huh? So I'd be interested to know if this curvature is related to this star's outflow that might be causing this to be opening into a cavity. I could be wrong about that. I don't know about what powers the California Nebula. But Darrell will probably be looking it up right now as we speak, if he didn't already.
I already have, yeah.
I knew it.
It's a prodigiously energetic 07 star, Xi Persei, also known as Menkib, which
this
is
guy?
seen. Yes, that's it.
Okay, and how? And so how is so that could be the reason why this is an arch, because it's very powerful stellar winds are causing this arch. So that's very possible. And we're only seeing this in two dimensions. That whole cloud could actually be like this, going around. So there could be some toward us, directly away from us, and then, or directly to that side, and then be, ahead of us or out there. So it could actually be this type shape too. It could be a big shell of gas that this star is blowing away with its stellar wind. So you know the distance of this star and the distance of the California Nebula, right?
1,000 light years.
Okay, for both?
I would have to guess they're close to each other.
I would think so. Actually, I can figure that out. Okay, so we'll come back in here, and if we just come in and look.
Star's name is Menkib. Menkib.
All right, Menkib. There it is, right there. All right, Menkib is given as a star whose distance is 1,244 light years, and the California Nebula is given as what? I want to find that out. Let's go back to this dark nebula here.
Yeah, I was just quoting Wiki, and
yeah,
you know how Wiki could. Although their scientific stuff usually seems pretty on. I mean, they reference their sources, and all goes back to popular databases.
Yeah, they do. All right, so then what I'll do is this. I'm gonna just for fun, just to get this straightened out. Let's see. Menkib is the one that's doing it. All right, California Nebula. Oh, the 1 second delay. We still don't have Starlink. That's going to be February, coming year. Okay. Well, that didn't help me, did it? Let's just do this again. I thought that by hitting enter it would do it, but all right. Yeah, welcome to the stupid. Oh, here we go again.
Bumble fingers.
Yeah, when it's a second behind, I want to see you do it right.
Yeah.
Okay. So the California Nebula now, and its distance is 1,304 light years. So that is consistent with Menkib's distance, which is, as we said before, it is definitely an 07.53, which is a giant star. And it's consistent with this 1244. So Menkib's a little bit closer to us. And so it could definitely be using its stellar winds could definitely be causing this arching that we're seeing in here. So there's Menkib, there's Menkib for real, and it could be causing this arching that we're seeing right here over our head. Really cool. So you're actually watching the universe in action here. That's really neat. So that's beautiful. So that's the California Nebula, and Izabela will be happy. That's 39 stacked. We'll wait for we're gonna just stop it there at 39.
I did it already once,
Yeah.
But it was before collimation.
Before collimation, that's right.
Collimation.
Yeah. So we'll save it again. When I save these stacks, Izabela generally has been using them more than anybody else as far as I know, but if other people have been using them, let me know. And then I'll save it exactly as seen. And we'll move on to something else. Hi there, Vera.
I learned something tonight.
What'd you learn?
Well, Menkib is what's lighting up the nebula.
Oh, yeah.
California Nebula.
Well, keep in mind that Menkib is going to go supernova, and I can't wait to see that. I hope it goes in our lifetime. I want to see a supernova nearby. Man, come on. What's that so much to ask? We don't have any stars near enough to us to cause us any harm at the moment. But as we go around the galaxy, we've done it almost 20 times so far since we were formed. It's possible that we might drift near or go by a star that could go supernova, and its debris could impact the Earth, strip our atmosphere, and wipe out all life on the planet in just a few short hours. But you know what? We don't have anything near us now. It would be another several tens of millions of years or more, maybe 100 million more, or maybe even more, before we actually would be near something of that nature. So that's okay. All right. So this was fun looking at this guy. This is, even on a moonlit night, this is pretty. Look at that.
Seeing the universe in action right there.
Yeah, we
bright
are.
Star making that whole nebula shine.
That's right. And we can see the cavity. Yeah.
I'm sorry.
And we see the cavity being created by this star too. This curved cavity with its stellar winds. It's blowing out in 3D. Remember, the universe is in 3D, so it's coming at us, it's going away from us, it's going to the sides. It's a sphere, and so at least out to this far, we know that it's probably given that no life could exist. Because the temperatures would be too hot, the ultraviolet too high. So, pretty cool. But, in some period of time, this is going to go supernova. Actually, that would be the coolest time. You know why? Because when that goes supernova, we'll be able to see what's called a light echo. The light echo is going to travel through this entire nebula. And you'll see this nebula change from one side to the other over a period of a few months to a year or more. I'm not sure how long. I don't know what the width of this is. I could take its distance, measure that, and use my program to calculate that. But that, we're talking about several light years long here, okay? And probably might take it a year. It might take the light echo a year to travel across this. Might take it some time to get there too. Well, what's the light echo? The light echo is yeah. Go ahead.
I was just going to ask, what is light echo?
Okay, a light echo then is an example like when a supernova explodes. Okay, there's a pulse that goes out, a bright pulse. That bright pulse is going to be like ripples on a pond. When you drop a stone, the ripples, and you'll actually see it where it affects matter in the universe. So you'll see when that ripple of light reaches this nebula, it's going to change the nature and brightness of the nebula, and you'll actually see a ripple moving through this nebula. Okay.
It is white light, or it depends on the.
It depends, but it's going to most likely be whitish blue, because it's going to be very, very hot. So because it's going to be so hot, it's going to move through here, and as it does, it's going to probably rip apart the nebula too. You might actually see some filaments forming as it drags stuff out. And that would be pretty interesting to watch.
Dramatic.
As the light echo travels, this is speculation on the actual shape of the nebula, but as the light travels through space, you can see it light up that lower wave first, and then later light up the upper wave.
That's right.
And you would see it propagate across that over the course
That's
of time.
right. And we will see
Mark,
that. Boy,
I sent you that article today about V838 Monocerotis and the light waves we've seen moving through it in the past.
Yes.
That's a V838 Monocerotis, folks. It was a sort of a nova that happened in the constellation Monoceros, which is where the Rosette Nebula and a lot of other neat nebulas are east of Orion.
Yes.
They've been watching this nova for the last 20 years. They have watched very discrete light echoes coming from the nebulosity around the star as the nova propagated. The light wave from the nova propagated out into space over time, and it lit up the different parts of it. It looks just cool as heck. I'll type that in chat if you ever want to look it up. Really
and there was
pictures of it over time.
There was a supernova, I think 1987A, that also had a series of light echoes that traveled away from it, and you could see those over a period of time as well.
Exactly.
Those are fun to look at too. You might want to, if you can find a link for that too, throw that up there. Let people see what's going on. All right. Okay. 1 second exposure once again. And let me go to my high processing mode here, and let's just, there's a few things we're going to check out, I think, that are worth checking. All right, and let's see. So you see, we learned all about the California Nebula. Didn't only just see a beautiful red nebula, we learned about the very, very hot blue giant star that powers it. And we also learned what might happen when that blue giant star goes boom. And that's coming. That's definitely coming. Okay.
I appreciate learning new things every time on the show I come. Every time.
I love it. I'm so glad you come with that.
I try not to miss anyone.
I'm glad you haven't. You know, you're very good. And by the way, folks, Isabella's the one that puts the table of contents in for us down below. And I'm just very, very happy, you know, at how you do that. It just makes me amazingly just very, very happy that you're doing that for us.
This is one of the ways to learn. It helps a lot with the learning because you go hands on the things, kind of.
Yeah. I'm gonna try this. might be hard to get with the telescope because we might have a problem with the roof getting in the way, but it looks like we're okay so far. We might have we're so far we're okay. I just have to make sure. So it's doing Hasselblad, which is the star right up here. We're just there a moment ago. Then it's going to go a little bit south to this nebula down here.
We in Orion now?
I don't think we're going to Flaming Star yet, are we? Maybe we are.
I just saw a star labeled something or other Orion.
Yeah, we're in. And this looks like the Flaming Star Nebula here. Okay, we were talking about the Flaming Star, and I thought we would go check it out. But let me just go back here.
Sure.
Yeah, we're in Orion for sure. Elnath, yeah.
Oh, okay.
Yeah. Yeah, we're dead center in there.
Yeah, Elnath is the tip of one of the horns of the bull. And it shares, that star is shared between Taurus and Orion, the charioteer.
And there's the tip of the horn that Darrell's telling you about right there.
Yep.
Yep. Okay, so if we come back in here now.
Orion's a charioteer. God knows why he's messing with goats. I never did figure that out.
Yeah, I don't know if we want to discuss that on an open stream. Oh, yeah. Okay, well, let's actually bring this down a little bit into the field of view. Oh, look at that. We got a little satellite right here. Watch right here. Look at this guy. There's a satellite going through. That's a 1 second. That's a 1 second exposure right now. So that means that this satellite, at that speed, this satellite is got to be. It may not even be a functional satellite. It could be a rocket booster, sitting at like several thousand miles up. You know. And when it's higher in the sky, or higher in altitude, in orbit, it'll be illuminated by the sun longer, and we'll see it longer. And usually, when you're at night, when you're out there, and you see satellites, you can see satellites at midnight, you know, even though there's no sun to illuminate them apparently. But when you see them to the east or the west, or to the extreme north, or sometimes south, depending on where you are on the planet, you can actually see them because, from their point of view, the sun is still up because they're so far out. They still see the sun from their position. So you'll see them. But
yeah, as a general
seen
thing, you tend to. Oh yeah, sure. Summer is a good time for seeing satellites very late at night because you know we're tipped that way toward the sun, and you'll see bright satellites at all hours. When we're in winter, well, the sun is a little more hidden, and you may not see them quite as well, but you can still see them, like we just saw.
Exactly. So this here is the Flaming Star Nebula, and there's a lot of nebulous detail here, but I have to pick and choose, so I'm going to move us up just a little bit. Okay, and then move it over just a little bit. Okay, and then we're going to let it settle down. We're going to check focus. As the temperature drops, the focus will change. And so we will also go back in and check our focus. And that's what we're going to do just right now.
Mark, excuse me a moment, please.
Go for it. I'll be right here. Okay, so now we're going to just check our focus. Let's modify this a little bit. Let's see if going up makes sense. Okay, gotta go down. So Izabela, tell everybody what time it is over there for you.
5:55 in the morning.
5:55 in the morning.
Yeah, it's nice.
See that, guys? Talk about
What?
dedication. Dedication,
You know-
man. That's dedication.
I was just thinking that when you showed the Flaming Star Nebula, and I could recognize it with closed eyes already. It's very interesting.
Yeah. See, you see these things enough, and you can actually recognize them, and that's the best part. It's kind of cool.
Yeah.
I'm going to go to this one before I go back to the other one. Yeah, see, that's what I thought. See, the 216 might be the number that we want. I can see the smaller stars. That's pretty good. Okay, we'll try this. So that means our temperature is now cooled down in the building. Actually, just so you can see what I'm talking about, let me bring this up again, and we'll go and look at temperature. We have a temperature system in there. We are looking at 57 degrees Fahrenheit, or in Celsius.
Oh, thank you for the Celsius.
13.9. Okay, so it's 13.9 Celsius in there. We're 57.1 Fahrenheit. So, what happens is, as the telescope contracts, as it gets cooler, the focus changes, and so we adjust the focus accordingly. This is going to make this image, you can already see that it looks just so much crisper right off the bat. And now, I'm just, again, prepare to be stunned. And we'll go 35 seconds on this one. All right, and we'll take off our hyper process mode here and go back to this and go into our live stack and clear the stack because it'll have the previous image in it. Oh, you gotta love that. That's already up on the server. For those that don't know, we have a server that's a live server, and it's free access. Everybody can look at it, and you can download all these photos. They're in a directory called Processed under each directory. When it comes time at the end of the stream, I'll go up to that server and I'll change all the names to what these actually were, and then we'll go from there. So this will be the Flaming Star Nebula coming up right now. Look at that. Wow. I'm gonna let another image come in before I change the color and do the. It's gorgeous. It's gorgeous. Look at that.
When I saw that picture done in the Hubble palette the other day, I didn't care for it at all. I think this is a much prettier image.
It is. It is. Okay, we're going to get our second one. The green bar right there is a progress bar. Okay, we have our second one here. And so now what I'm going to do is I'm going to fix the colors. Okay, this will just get rid of that green tint. Now you got the proper color. And now what I'm going to do is set the proper balance of the color so the background is blacker. Okay, so now watch how this jumps out at you. Look at that. Oh, wow. Wow. And as I said before, the noise that we see in the image, this modeling, okay, that goes away over time. Notice the very important thing. This is blue here amidst the red. See that blue thing right there? This is dust. This is a lot of dust, interstellar dust, and it's mixed with interstellar hydrogen. Hydrogen gas in the cold of space can be atoms or molecules, but the atoms can be ionized, and again with hot stars, such as this one right here. This star is ionizing a lot of the hydrogen gas, and that hydrogen gas is then glowing red because of that. But the blue is not ionization. The blue is what we call reflection. And I say what we call reflection like you don't know what reflection is. in astronomical terms, you may not, because what's really happening is the dust particles are actually absorbing all the light that the star is giving off, but they're passing through most of it and taking the high frequency light, and see, I told you it gets complex, and scattering it in all directions. And that's blue for the same reason that the sky is blue. It's doing a particular kind of scattering process called Rayleigh scattering, and the dust particles are doing it to the high frequency starlight. And what's high frequency starlight? The blue light. We have red, orange, yellow, green, blue, indigo, and violet light. Well, this blue, indigo, and violet light up here, this is all high frequency light. And this high frequency light is really short wavelengths and can be scattered very, very easily. And that's exactly what we're seeing. And that's why it looks blue. All right, for that reason. It doesn't necessarily mean that the starlight is all blue, because it doesn't have to be.
And that is exactly one thing I looked for and could not see in that Hubble palette image.
Is this little blue thing?
Yes, it was lost in all the other blue and weird colors going on.
Well, see, because we've got it focused, I think, pretty good, we can go to 50%. You'll see some of the noise. We're not even at the full size for this, okay? I mean, if we go to full size, this is, I'm going to show you the natural size of this image, okay? I'm shrinking it down to fit on the screen. But check this out. Here, right here, this is the natural size coming up. Boom. That's the natural size of this image. Okay, that's the size the image wants to be. All right? So, this is just so incredible. Look at this blue, this beautiful blue reflection nebula in here. Look at this weird tendril. This has a reflection nebula component. It has a dark nebula component and a hydrogen glow. You see that? All in one beautiful tentacle of dark nebula. There's gas mixed in that's glowing. There's dark nebula that's scattering the blue light from the star. And you have the dark nebula behind it that's not doing any scattering. All right? So that's the kind of, I mean, this type of stuff was lost to us until we actually took the time to get the telescope aligned properly. And we never knew it wasn't aligned properly until I got out there, and well, I knew by looking at the images, but we could never see these kinds of details. We could never go to 100% of the image. And I can actually go to like 200% of the image, and it'll be pixelated, but you can still see detail. See, like that beautiful little, almost looks 3D. You know, this thing right here. Isn't that crazy? Just beautiful.
It's fantastic.
So we'll let this stack for a while. We've captured 9 so far, and this is the Flaming Star Nebula. And by the way, I just implemented a technique to take stars out of the image entirely for purposes of just working on the stars separately from the nebulae. And I might be able to show you that here. So I'm gonna go open something up here to show you while that's stacking. So we'll do that. I think I know where it is. Here we go. This is the one, right? Yeah. Okay, those of you might remember the Elephant's Trunk Nebula that we've taken pictures of. I'm going to show you 2 versions of it. Okay, so just a second. Let me go grab it. Yeah. So how are you guys enjoying it so far? You liking it tonight? Let me know out there. Okay, and then we go out to this add-on drive. Go out to SkyTour Livestream West. And then we look for our amazing Let's see. And that's that one. I'm looking for the elephant's trunk, the other one I did. Alright. Alright, here we go. Alright. Getting it now. And then boom. Here we go. And then this guy. Okay. Let's see here. We're still stacking. Look at that. It's really stacking beautifully, isn't it? That's just looking so stunning. Okay, so you might be familiar with this, right? This is the elephant's trunk that we shot. Yeah. And we'll probably shoot this again. All right. There's another version of it. Okay, a little bit different processing. All right. But this one is what I started with. And let me show you now. That's beautiful. Let me just get rid of that stuff in there. And now let me bring up the other image that you need to see. This is the image of our starless elephant's trunk. And believe it or not, it might be hard to believe, but when I show you this, you're going to look at this and say, that's different. That's not the same. Yes, the stars are gone, but believe it or not, the entire... I went to the wrong place. No, that's not right. The entire image, the entire structure is identical in every respect. All right, and you'll see that when I show it to you. There it is, StarNet++. There we go. This guy, and here it is. Okay, this is identical in every respect.
But you didn't process this yet, right?
Yeah, I did. I processed this the same one. This is the same one I processed before, but without the stars. You can see the nuances of the nebulae in a ways that you just can't before, you know? Like, for instance, you know, we look at this over here. I'm sorry. We look at like this beautiful structure here. You can't see that when the stars are there. You look over here. You can't see this very well when the stars are there. Having the stars there kind of detracts your vision from this. You don't see this. You don't see this very subtle stuff. All right? But you do when you remove the stars. It's really a helpful technique and analysis. You can still see some ghostly images of where the stars were. All right? But if you check it out, remove this, the stars are being removed with an artificial intelligence algorithm. And then I can bring them into Photoshop, all right? And in Photoshop, basically, I end up having two files, which is kind of neat. We're still stacking, by the way, on the other one, so we'll have time. So let's see now. Let's go out to the Lacey, my archive for Sky to Livestream West, and let's take a look at the elephant's trunk. Okay, this is the one we saw before. Okay, it's coming in. All right, and then so there it is. And now let's open up the starless. Well, you saw the starless one, but I'll show you what I'm doing here. So now we'll go out and go to this drive. Go to here. Go to here. Open up this guy. Okay. It's coming in. Alright. So now I have that guy there, and I have that guy there. So by selecting this, I'm going to go down here, and I'm going to run this little program I wrote called Star and Nebula Separator. So there we go. I'm going to run it. Gives me some instructions, which I'm doing now. And I continue, and it's now going to separate my images out for me, and it's going to separate the layers. So
That looks like I need to clean my refrigerator.
doesn't it though? So here we go. So here we have, now this is the same image with stars and without stars. Turn them on, turn them off. Isn't that cool?
Yeah, it's cool, but I'm missing in this one without the stars. I'm missing these two little stars inside the eye of the elephant trunk.
That's right.
They're very cool.
That's right. We shut them off. That's why. Yep. What'd you say?
That looks like something I scraped off my shoe.
Well, most nebulae do, Darrell. Darrell said, if you didn't know if you heard him or not, it looks like something he scraped off his shoe. Well, yeah, that's true.
I thought it looks to me like elephant skin.
Yeah, that's true, huh? So that's kind of cool.
That's a pretty picture.
Yeah, you got to talk louder, Darrell. For some reason, you're low again.
I'm sorry. I think my settings are where they always are. I'll try to speak up. That is a pretty picture.
Yeah, it looks beautiful. Mm-hmm. I want to say hi to Dennis and Manfred. How are you? All right. And, yeah, almost like a coffee creamer and a cup of coffee. I guess. So we've got, how many frames are we saying? We've got 24 stacked here. So why don't we zoom in and take another look at this beautiful nebula before we move down south of it just a little bit to some more details below. Let's go to 100% on this. The center in the middle. Look at that. Isn't that beautiful? All that noise we talked about is no longer there. It's gone, you know. And what we can do is we can go into our live stack and we can actually adjust our black level a little bit more and just bring out a little bit more detail in this. Okay, I mean, look at how that can be detailed and colored right up. You know, that's a little too much, but just to show you what it can do. All right, and then we'll back out and show you how crazy bright and how wonderful we can make these nebulae look. Look at that. That's kind of cool. What I'll do though is, but you see more of the nebula, which is kind of cool. What I'll do now is I'll just change that back a little bit, and it gets a little brighter. And that gives us a more balanced view of what's really there. So you see more over here. Neat, huh?
Wonderful.
So we're going to pause this.
So
we're going to
beautiful.
save it. We're going to save this at 26 stacked images. Actually, I should have waited 2 seconds longer, and I didn't. That's okay. Actually works. Okay. And we're going to save that. I think I just did it again. And then we'll save the image just as you see it here. So that if you don't want to have to deal with stacking your own or playing with stacks and bringing out detail like I was doing in the Photoshop there for a minute, you can just download this beautiful image and be done with it. You don't have to worry about it. And that's what we do. We like to give you beautiful images to take down and just use anywhere on your wallpaper or whatever you like. And I do got to thank my company, fxmodels.com. They, that company has provided all the funding for the electronics that has gone into the observatory. The GoFundMe provided the observatory and the telescope, and I have to thank all my sponsors, all the people that offered up some donations, especially Marianne Robb and Tara Diulis and others who have given tremendously to SkyTour livestream. But we're working on new things to do, so we're going to be springing those on you sometime soon. And we're actually expanding a little bit to try and get ourselves into a position so that we can get other observatories and other locations to do other things. Yeah. Get crazy. I'm downright nutty, actually, but that's okay. Anyway, let's go back here. And let's zoom out a little bit and go back to our position of the scope. Zoom in a bit. Okay. And now what we're going to do is we're going to drop the telescope down a little bit lower. If you recall, we were doing this right here. We're going to come down to here now and capture a very different looking set of nebulae. Alright, so we're going to do that now. Let's bring the telescope down. Let me change this to from 16x, let's change it to just 1.5 degrees per second and see how that works. We might have to... Okay. The wrong way. Alright, let me bring it back up. There it is. And now what we gotta do is move it to the east. Yeah, there it goes. Okay. Now let's go look in here and see if we've got something. Okay, let's move it over a little more. I'll actually go to the star. Alright. We're going to Scioriga, which is... Uh-oh. I hear Buddy. Is that your dog, Buddy, Izabela?
Mm.
It was, wasn't it?
Yes.
Yes, that's cute.
I cannot help it. He's too big. I cannot fight him.
That's okay. No one's saying you have to.
He's a good boy.
Yeah.
And he loves astronomy. You know, he listens with me.
Yeah.
Every time.
Okay. We're brought in Elnath and then we go here and there you can see the nebula. And the cluster and the other nebula over there. It's just, this is a nice rich area I thought would be kind of fun to look at. Okay, so. And let's go down here. Okay, so we are trying to look at that nebula right there. So what I'm going to do is I'm going to move that in. Center it up, and I'll tell you what it is and look at it in just a minute. We'll check it all out. So move over. Got a beautiful cluster up top there. Because the telescope is flipped backwards, we're actually backwards a little bit, which is it's opposite of what you might think. It's going to be opposite looking. Okay. So let's go to... Yeah, that's good for now. Now let's go over here. Alright. Alright. And so... Yeah, okay. So what I'll do is come back to this. and set our position on that star. Okay. Okay, so all right. Okay. Let's do a 25-second shot here just to check out what this area just below. Now, the Flaming Star Nebula is up above all this. We're down below that. Okay? So I'll just show you that this is Auriga, the constellation Auriga. Alright, 25 seconds. And we'll try doing that with a stackeroni. And we'll clear the last stack. That was the Flaming Star. And now we're down below this. So this nebula continues down below. And we're down in that region now, looking down below. Darrell, if you've got anything you want to look at tonight, please feel free.
Okay, well, whenever you're done here, if you like, since we're in the neighborhood, maybe go over by the other tip of the bull's horns.
Oh, yeah. We can do that.
You know what I mean.
I do.
What is there?
You'll see. It's something that we talked about earlier tonight, actually.
That's interesting.
Yeah.
I was seeing this before.
Yeah, this is, I'll show you. We're looking here.
Mm-hmm.
Okay, and if we zoom in, there's this beautiful nebula here, which is odd because it looks kind of gold, like the like the flame. But it's actually interesting because of what it's got in it. It's got several elements to it which are interesting. It's got this thing, it's got this thing. We go here, okay. Alright. It's this thing and it's that thing. Okay. But there's also a reflection nebula up in here too that has to be brought out. Or this is part of the rest of the nebulous detail in this region. I mean, it's really just, it's so rich. And look at this. This is all glowing hydrogen gas here. That's all this red is. It's not an error. Okay, that's what this is. And if we do color correction here, it's not going to go very far. So it shows you even better. If we do this, if we actually now do a little stretch, you can see a little more detail now into all this nebula. So much red glowing hydrogen in the universe. So much.
Looks like dragon.
Yeah, it does, doesn't it?
With this eye.
With the eye and the ear right here, right?
Yeah. Mm-hmm.
Yeah. It looks like a dragon. Yeah.
Even the nose.
Yeah, this is the nose right here.
Yeah, exactly.
The eye, ears like back because it's angry.
Right.
And it's spit a fireball. Or it blew its nose in a.
Do you see all the star trains delineating? Like what I think you called the ear of the dragon.
Yeah, right here.
Yeah, you see how those stars just follow that edge so neatly?
Yeah, it's kind of cool.
Yeah, there's a bunch of lines when you kind of open up and look.
Yeah, I wonder what physical process may have led to stars forming like that. Now, we know about shock waves with supernovae that could actually cause successive shock fronts. They could cause chains of star formation. That's something it could have been. But this is really different from that. But then again, if we look at these star chains up here that Darrell's talking about, sorry, let me get rid of this here, and let me just pin that. This is just beautiful. Let's bring that up. Wow. I mean, you see star trains everywhere here.
Oh, yeah.
Wow, but the ones you're talking about are like this one.
Yeah, and there were others in there as well. To the upper left of that, there was quite a chain of them.
Yeah?
Yeah.
Well, let's go find them.
They look to me like they're exactly on the edge of the darker nebula.
Yeah.
Yeah,
like
exactly.
drawing an outline of.
Yes.
Exactly.
Yeah.
Yeah, there has to be something. There has to be something to that. It's more than just coincidence. Some of it can be coincidental, but this is really quite exact. So there's probably something to that probably needs to.
Yeah. If
It's
you
like
look
a
at the.
paper.
I'm sorry. Go ahead, Isabella.
It's like a paper. When you burn a paper, it starts to burn from the edges.
Yeah.
Yes. That dark area to the upper left is the brightest part of the nebula. That farther down, closer. About halfway up toward the top.
Right here?
A little bit to the left of that, just a little bit. To the left. That dark lump right there, you see stars all around the edges of it too.
Oh, like right here?
There and up toward the top edge of it.
Yeah.
Up a little bit.
It's true. And I think that if the other thing too is we have to be careful, because if there's a dark nebula and there happens to be a whole bunch of stars in this area over here, for instance.
Yes.
Then the dark nebula will automatically, the edges of the dark nebula will automatically add some shape to it.
Exactly.
So we have to be careful about that too. We're not really sure. So we can't leap to that conclusion that that process is something that's happening with dark nebulae. But if we zoom in, okay, and let's go into, we're over 100% now. Now we get in this far, and you can see that the line really isn't as clear a line as you would think.
Yeah.
You know, it goes like this, and then it goes down here, and then maybe up here, and then over and up and back. It's really not a line so much as perhaps your brain drawing logical lines where none exist.
Oh yeah.
That's I mean, it may be a line, but I don't know.
When you zoom out at this image, because the star field is so rich, that I see those dark lanes wandering all over it, you know. And maybe it's just my eyes trying to connect the dots.
I see them too. They're
Yes.
on the right, right?
No, it looks like they're there. You're seeing the voids in the red nebula, and it's possible that they're dark nebula, or it's possible that it's just areas that are not excited gas.
Where I see them is down in the lower part of the image, the lower right and the lower left. I see big dark swoops, lines going across.
Like here?
There.
Here?
Like
Over on the
waves.
left.
Like,
You see the dark lanes in that?
Yeah.
yeah.
Well, there could be dark dust in here as well. And we're only doing a 25-second exposure. I mean, if I was to, take and do like a 2-minute exposure, that might actually show us a lot more. And the gain is just like half of what it can be. So I can even bring the gain up higher, but I'm not gonna cause the images to be lousy quality unless I'm doing it like for research, to see.
Yeah, I don't.
Yeah, okay.
I don't know if it's just pareidolia or whatever that I see those in some images. It's like there's that one up in the northern sky this time of year. I always say I see spider legs in it.
Yeah, I remember that. We talked about that. Yeah.
I see them.
Okay.
They're narrow, dark lanes, and they're going kind of swooping and curling around there on the lower third of the image.
Yeah. We're going to pause this and save it.
In general, matter is not evenly distributed in the...
That's right. It's not evenly distributed, and that's part of the problem. You know, because it's not evenly distributed when there's a supernova, such as those that we've seen before, then they can cause some serious issues because these supernovae will pile up material as they explode outward. So if there was any even distribution, a supernova wrecks that right away because it's clumping stuff up by pushing it out. It's like going into a room that's full of foam and pushing through the foam and pushing all the foam against one wall. You know, if the foam is the interstellar matter, you're causing it to be more dense on one side than the other by pushing on it. And things can happen when that happens. When you're talking about stars and you're talking about gas, and it's the gas that's compressing, it can get hot, and it can actually, you know, dark nebulae can condense and gravitationally condense and form stars with the gas and so forth. And then those dark nebulae that are surrounding them can also form a nebula from which planets can form in all of that heat. And eventually those planets could be life-bearing. We don't know.
Speaking of supernovas.
Yeah, that's right. That's what I'm doing. Just getting rid of this. You got it. Be a good night to try that too. I gotta wait to see just how far up it is, because it might not be high enough right now. But it might be. We'll see. We're in that neck of the woods, as you said. Okay. No, Betelgeuse is already up.
Yep.
Okay. So where we're going to go now is we're going to go into Taurus the Bull. We're going to actually go kind of near the horns here. Taurus the Bull. And I think it's high enough where we can actually pick it up. But one thing that might be interesting to see, though, is the ruby star. This is cool. You want to see a real cool supergiant? This is it. Let's see if we can find it. Let me get rid of the timing.
Is it
here.
red?
Yes. Oh, it looks like the telescope is going to have trouble finding it. Maybe not. Let's find out. Well, maybe not. Maybe not. Okay, so we're getting a particular star here for our hopscotch to another star. Oh, look at that. I think we'll see it. Yeah, there's a beautiful red star known as the ruby star. We'll just take a singular 10-second photo of this. Okay, so this is what it looks like normally. We'll do a 10-second shot, and then we'll give it a little increase here. Look at that.
Oh.
What a beautiful star that is. So you'll just increase the, give it a little more brightness. Isn't that a beautiful star? Hello, Laura Newbert. I didn't see you there before. I'm sorry. Good to see you. Yeah. And now we'll head back to the other star. I just wanted to show you that real quick. And we'll go check out the other object that we want to see for real here. Okay, here we go.
Crab Nebula.
So yeah. Have you seen that before?
Yes. Here.
I think you have.
I think we saw it the last time. Or the time before.
Yeah.
It's that time of year.
It is. All right, and we're going to be... There it is. It's up there, but we're using the star near it as a hop-off point, and then you'll see us go right up to it and put it right in the middle. There we go.
It's
Ain't it
unbelievable.
cool? Yeah, it's pretty cool. And that's where we are, is at the Crab Nebula. Let me just drop us in there. And I also want to align us on that thing. Okay. So now we're at the Crab Nebula. And the Crab Nebula is a fascinating supernova remnant. It was seen in 1054 AD by the Chinese astronomers, and they logged it as a star that they could see during the daytime. And as a star they could see during the daytime, it obviously caught a lot of people's attention. And that is what this is. It was a star that blew up. Now, it didn't look like this. It was just a bright spot in the sky. And if you looked at it with a modern telescope, it would only have looked like a very bright star for the longest time. But then, over the years, since 1054 AD, this debris field, this debris material has been spreading outward from it. And this has left us with this nebula here. And in the middle of this nebula, which I think if I zoom, you can see it even now. Let's go to 100%. At the middle of this nebula is an object known as a pulsar, the Crab pulsar. And I think we have to wait for us to take a few exposures. Focus looks pretty good, but you can see it. It's barely there, but you'll see it here in a minute. So watch this. Actually, I'll leave it here so you can see it. That's the fuzzy cloud. That's the Crab Nebula. But I want to show you something. Watch now. Is we take this and we go, say, do a 25-second photo. All right. And a 25-second photo, and then we're going to go stack. All right. And we're going to get rid of this right here. All right. And let me just do this too. All right. So we're almost done. The green bar is almost full. And then you'll see this amazing nebula. There it is. And it's got some noise in it. But I just have to get rid of the noise here for a second. So let me do a color correction, number 1. Okay, there's a color correction. Now let's actually do a little bit of another correction here. I'm going to do it this way. Yeah, see, now another one came in, and look what happened. That noise just almost went away. And look at the dot in the middle. That is the Crab pulsar. That's a star the size of Manhattan Island. Okay. New York City's Manhattan Island. And it's rotating over 30 times per second. Okay. Isn't that incredible? That's the star right there. And we can see it from all this distance. And when we come back to our planetarium view, right, the distance to this is around 6,524 light years, roughly. But that's not accurate. It could be 1,000 more or 1,000 less or more. So it's not exactly accurate. However,
pulsar, yeah, sorry.
Go ahead. No, say it.
Is pulsar and quasar the same thing? Quasar?
No. Quasar stands for quasi-stellar object, and it's not quite the same. A quasar is something that could be at the heart of galaxies and powers a whole galaxy. This is just the remnant of a star that blew up, and it just blew all its outer atmosphere off, and its core blew out, and then the outer core rather blew out, and that's after the whole star. The way it starts is the star actually was doing nuclear fusion. It was putting out a lot of energy, okay, and then it ran out of those fuels to create all of these elements that it makes in its core, and so it stopped suddenly, and it collapsed, and all that mass, more than 30 times the mass of the sun, just collapses into the center, smashing that core under so much pressure. And at the same time, the star doesn't all collapse. It's collapsing. It's in the process of collapsing. The core collapses deep inside, and it collapses, and then it rebounds off that core, because what's in the very, very center is very likely iron, which is very hard to compress into other things. So that rebound effect is now shooting outward from the star. It's shockwave going out in the star while the stuff is trying to come in. So it's going past it, and as it's coming out, the stuff pulling in is actually being ripped to pieces by the stuff flying out, and the whole star is destroyed. There's the term that astronomers use is disrupted. Okay, the star is disrupted, but hey, let's say we like to confuse you. That's why we say it. So it's disrupted, and so when we see a disrupted star, we see a lot of turbulent side effects, like these filaments here. Look at all these filaments. Actually, Darrell, this is a really pretty shot of it, and we're at 100%. With only 10 stacked frames. That's not bad. We can even stand to go a little more.
Other nebulas like supernova remnants, in the veil, and planetary nebulas. It seems like the hydrogen goes some places and the oxygen goes other places. Where you see red areas and green areas.
Yes, you see green down here and around here, and you see some red here, but they're mixed throughout. The tendrils are actually mixed throughout, but it does appear that sometimes the oxygen and the hydrogen do somewhat different things, apparently. I'm going to add some sharpening now to this. Watch the Crab Nebula now. Watch this. Ready? I'm going to click, and now watch. Oh, look at that. It just got a lot sharper. See that?
Yeah.
I just actually sharpened it dynamically. It doesn't affect the actual raw data, but what it does is it actually It actually shows you visually what's going on better. The pulsar stands right out now. I'm going to drop the amount that we're sharpening down to 1.5 or so. That makes it a little bit better.
What wavelengths is the pulsar pulsating at? You know, the search beam effect. Ultraviolet, radio?
I think it's in the radio, but I think we'd have to look online to find the exact frequencies. You know? But that's a very good question, actually. I'd like to know the answer to that myself.
Challenge accepted.
And there he goes. He's off and running. That's good. Yeah. But isn't this beautiful, guys? Check this out. This is a beautiful remnant of a dead star. And what's left in the middle there is a very, very hot star that's 6,500 plus years away from us. And yet we can see it, and it's the size of Manhattan. Let that sink in. We're seeing it visually with our eyes. That means that this star core remnant is so hot that its energy is reaching across 6,500 light years so we can see it. And it's so small.
12 miles
we have no business seeing it. What's that?
It said 12 miles in diameter.
Yeah, that's right.
And we can still see it 6,500 light years away.
Yep.
Unbelievable.
Yep. Now the pulsar, it does have in the radio spectrum you do get a flash. You actually if you slow it down, it'll be going in a very like clockwork. You can actually set clocks by it, atomic clocks. But pulsars are also, due to the nature of what's going on around them, and the drag associated with a spinning dead star and the stuff that's around the star, it adds a bit of drag. So over time, pulsars will spin down. You know, it just takes a long time. And eventually, the Crab Nebula will no longer shine because the pulsar in the center, which is powering it, will eventually not have enough energy to ionize, but that's many billions of years in the future, probably long after all the stars you see in this image are even going to stick around. And many of these are in the foreground up here, and some are in the background. The nebula's out here, and many stars are up in the foreground here. So you got to remember that we're looking at the universe in 3D. We're actually at 150% here, and it's not bad. Yeah, go ahead.
Well, I'm looking at Crab Pulsar, not the Crab Nebula. And
there's a high frequency component to it too, by the way. So I mean,
yeah.
So you're going to see it's going to be a high frequency component as well, because it's very, very hot. So that means very blue, way up in the the high frequencies, almost gamma rays area.
Exactly. It's saying X-rays, gamma rays.
Yeah.
High energy cosmic rays.
Yep. But the thing is that the pulsars, yeah. What we're getting at, what Darrell's getting at is it's a broad spectrum. It's a broad spectrum response that we see from the pulsar. And that's really cool. This is gorgeous. Holy cow. I'm amazed. This really looks so fantastic. It borders on some of the, I don't know. I hate to even use the word Hubble in the same. It's not like the Hubble. It's far less capable, but we're seeing a lot of the detail that the Hubble has seen. Wow. I'm going to dare to go up to, let me go up to 800%, all the way up here. This will be too bright and too big. Not too bright, but too big. But let's just see what we can see. We're into the world of pixelation now. But let's just go check out. Check out the Crab Pulsar here. Look at that. Let's drop it down just enough. Let's go to 400%. And there's the Crab pulsar. Wow. That is really cool.
It is. It's something.
Let me see if the color correction will help us or hurt us now. I'm going to go back to my histogram and perform another color correction. See what this does. Okay. We're okay. Now I'll do this other... yeah, that's what I wanted to see. So as we do this, we're going to drop this down now. Because it's actually too bright. It was actually too bright. Can you believe it? Wow. And now let's do this. Bring this black level down. There we go.
There are such energetic things going on there that I wonder if what we're seeing, you know, are like whole different spectral signatures or something.
Well, you got to remember that the entire guts of the star were obliterated out into the interstellar medium. So we're seeing more than oxygen, more than hydrogen. We're seeing many, many other elements in here. If you look up the spectrum of the Crab Nebula, you'll see a veritable plethora of elements in this spectrum. So we're seeing a lot more. So that's beautiful. So this is, we're going to go to 30 stack, then we'll stop on this one. So just a few seconds more. You can see the countdown over here. We got 3, 2, 1, 0, and then boom. And that's added in. Okay, now we got 30, so now we're going to pause it. And we're going to save it. So that we can do our work on the saved stack. And then we're going to save it exactly as you see it here. So you can have a really pretty picture of the Crab Nebula. So I hope you guys like that. And now we'll clear it. Get rid of this. And now go back to 1 second. Let's go see what else is available to us right now, shall we? Yes, we shall.
I'm going to post this. People can look at it if they want. They have a really cool picture of in X-rays of the Crab Nebula taken by the Chandra Observatory, and
nice.
in it you can really see the jet coming out of the pulsar.
Okay.
And it's an X-ray spectrum, so
it's an X-ray jet, so
yeah, it's tremendously hot and energetic.
Yeah.
We get this.
Hey there, Kathleen Marsh. Hi, Kathleen. Hi, Jessica Stankiewicz. How are you? Kathleen Marsh is with us. Have you seen any ships? We saw lots of satellites tonight so far, but we have not seen anything other than that. Now we're just looking at some interesting, beautiful, cool natural phenomena out there. And I will zoom out of this. This is our linked planetarium that we use to check out things. Let's try something else here.
Well, I should have posted a link to that image.
It's okay.
There it is.
Okay. Alright, so what we're going to do now is we are going to just go south a little bit. And we'll go up to 1.5 degrees per second again. Head south. Head east. Okay, and then we're going to head north. Go south a little bit. And let's go back to this. Now let's do this. Right. North. Gemini. In Gemini.
Huh. I didn't know it was called the shoe buckle.
Hey, welcome to Stellarium.
Yeah.
Yeah, now we'll move it over a little bit. This went a little too far, but we have one little guy here. Okay, gotta slow myself down here. Okay, now this is another very interesting object. We just all right. Do this. 25 seconds. I haven't been putting in titles tonight. I've been remiss in doing that. Now, Sofia Bulgaria has people in it that do analysis of our imagery, one of whom is with us tonight, and I suspect she would be able to tell you what this is.
This
she
is
knows.
the jellyfish.
Yes,
Nebula.
it is. Very good, very good. I didn't want to tell you. I wanted to let you see it.
And
Go ahead.
it is a supernova remnant. But as far as I know, it's too old and doesn't make any more stars, or not too much stars, not as much as other nebulas. But I just read a few days ago, actually yesterday or the day before, that there is a pulsar also in the jellyfish.
Mm-hmm.
I don't know how to explain you. Do you know, Darrell,
okay.
where is the pulsar?
I don't, actually.
Because I know approximately there is like a group of stars, which if you go from the big star with the halo, if you go to the left, right, and there is a group of stars there.
Here?
More, a little more left, more. This group of stars. And now down, you go down on the tentacle, or I don't know how to call it, on the tentacle of the, you travel a little lower on the tentacle. Yeah, somewhere there. I cannot tell exactly where. I saw it on the picture.
Okay.
But there are so many stars there, we have to clean the stars from here to find it.
Well, you have the methodology, you have the AI to do it now. I gave you that earlier tonight, so you should be able to do that. Yep. Isn't that great, though? That's very cool.
AI is a cool thing. Yeah.
Yeah. Also notice there's something else going on here, too. There's a lot of dust in this region, and we're also getting a little bit of that. We're also getting oxygen, actually, over here. We're getting the O3 here. But mixed in here is also dark dust and stuff out in here. You can see some of the darkness. If we did deeper shots, you would see it all mixed in. But there's some O3 right here, which is that bluish green glow. You see that?
Mm-hmm.
So we have that. Yeah, we have that too. So it's a very interesting nebula for sure. Jellyfish is a lot of fun. And we'll let that go for a few minutes, and then we'll come back and take care of it. But then we want to head just to the west a little bit to go to the Horsehead Nebula. So that'll be kind of fun. The Menkib.
This one is very strong with pareidolia. How pronounce
pareidolia?
Pareidolia.
Yeah, pareidolia. Yeah.
This is why I avoid it, because
you don't want to see a monkey head.
Yeah, because when you start to work on something and you always see a monkey head, and you start to paint a monkey head, you're
that's
looking
funny.
at it like
Like
you start to emphasize on the stuff that will make it look more like monkey.
That's right. That's right. It'll make a self-fulfilling prophecy.
Exactly.
Yep. So you're enjoying your time here with us tonight, Izabela? She's on mute.
Enjoy tremendously.
I'm so happy.
And, I'm so
You're
grateful.
doing fine. Oh, that's fine. And you'll notice people in the chat are just loving you. They think you're great. So we're going to have you on from time to time as well, and you'll be able to enjoy our company, and we'll be able to enjoy yours. And everybody will be able to enjoy your company. It'll be great. Hey, Jessica.
Yeah.
Yeah. Boy, this is pretty. Yeah.
It's difficult to be on this side of the camera when you cannot tell everything that you're thinking, because right now my head is exploding.
Why?
And there's so many things I want to say, and
We'll say them. We got time.
I'm practicing.
We got time.
Practicing.
You're doing fine. Bonnie puts a monkey head. Yeah, we're gonna go with the monkey head after this, Bonnie. You're right. That's funny. Yeah, obviously you guys can see why this is called a jellyfish, right? So this is the top of the jellyfish, and these are the tentacles, basically. But the other thing too is when we look at a supernova explosion, we tend to think that it just blows outward and evenly in all directions, and for the most part that should be true. But as Izabela even said before, the interstellar medium is not the same everywhere. It's not homogeneous everywhere. So that means that there's lumps in it, and it means that there's densities in areas where there's some high density locations, low density locations, clumps everywhere. So when a supernova explodes, it's shooting outward all this material. Well, if it had nothing to hit, it would be a perfect sphere all the way around the material going out. But that's not the case. That material shooting out is striking dense areas and areas that have less density. And when they strike a dense area, what happens is this. If this is the dense area right here, okay, this supernova expanding out to do this, it'll be stopped in part by this dense area, and this stuff will just keep right on going. So it'll tend to make this long, drawn-out filament, all right, a material. And sometimes it's not. Again, it's in 3 dimensions, so there might be a large knot of density, and this material might just go around it like that and leave a blotch in the middle. So it might make this weird butterfly shape of material. An infinite number of combinations and possibilities exist, and that's kind of how the supernova will work. The physics of the supernova will work, and that relates to how many stars could be formed by the supernova shockwave, if any. And how much effect the supernova will have, to what extent, to what distance. If it was unimpeded, then the supernova shockwave could expand forever, and would get it would get weaker as it goes further, but it would be unimpeded and could keep going until finally it hit material to stop it at some point. If there was no material ever, well then we would have been hit by every supernova that ever went off, except for that ones that are more than 4.6 billion light years away, right? So that's the age of the Earth. So that said, we're lucky the interstellar medium is not the same everywhere, or is not free of material. We're lucky that it's got knots of density, because that kind of acts like a protector against shock waves and so forth. So that's kind of where we're sitting right now. Is we're in a spiral arm that's actually rather quiescent. We're not having any massive bursts of star formation like we see in some galaxies. So in case Darrell or Izabela wants to say something, I'm zipping it.
I was wondering, where is Darrell?
Oh, I'm here. I'm sorry. I was reading up on the jellyfish, trying to figure out where the neutron star is. They talk about it, but they don't show just where exactly. There's a good bit of the nebula that's going off to the upper right, actually.
I saw a picture with a circle.
Upper right? You mean upper left?
Upper left, yes.
Okay.
What we're seeing is just part of it there.
Yeah, we got a reflection nebula here too.
Yeah.
Going up there.
And the neutron star, they say, probably is from the supernova that created the nebula.
Yeah.
Like the crab.
Yeah, keep in mind the supernova, you know, it has its own speed moving out, but the star itself is moving as well around the galaxy. So if it happened like 50 million years ago, it's possible that the debris and the remaining pulsar or neutron star itself might actually separate themselves a little bit from each other through independent motion and in interaction with the interstellar medium. So that's very possible. Okay, we're gonna.
I would think it's still in the neighborhood. They say.
Yeah, sure. It'd be in the neighborhood, but it doesn't have to be in the center. Is what I'm saying.
Happened 3,000 to 30,000 years ago. Surprised they have that big a gap for it.
They're notoriously hard to figure out the age of. There was nobody around to see it.
Yeah, it's about 5,000 light years away.
Yeah, so we're seeing it as it was 5,000 years ago.
Yeah.
Okay, I'm going to. I saved this one out, so I'm going to clear it. We will now go to the monkey head. Alright, let me just get rid of this. I forgot to. We're looking at sort of different things than we did last time, so this is kind of fun. Alright, let's go to our process mode.
Monkey head looked very colorful in Stellaria.
I guess we'll find out if it's really that colorful. I suspect that it's going to look pretty colorful. Alright, we only have to just move a little bit, so we're going to do that. We're going to go and do this, which is 1.5 degrees per second. And we have to move to the west a little bit. And we have to move south a little bit. And let's see if we can get it in here. There it is. Das ist der monkey head. Okay, and let's go like this. Hey, OG Skywatch, what's going on? And we're going to go to that.
Oh, okay.
What? What was that? I heard a bloop bloop. Was that you?
No, somebody sent me something.
Okay.
I suspect Izabela, showing where the location of the
pulsar, neutron star.
Yeah, the pulsar.
Yes, this is from my website. And I circled there the pulsar and wrote the name of the pulsar.
Okay. Well, while we're stacking this, Izabela, we're going to go to your website. So we're going to check it out. So, can you send me the link in the chat?
Sure.
Thank you. And then I'll just take us there. All right. And let's do a 35-second exposure on this. The monkey head's going to be pretty, guys. You're going to like this. Lots of dark nebula in here. Really interesting look to this nebula. See if you can see a monkey's head.
I seem to have lost my Skype. Can you still hear me?
Yeah, I hear you.
All right, I can't pull up my Skype screen now.
What? I hear Buddy.
Oops.
That's okay. I'm not upset. She can stay off mute. It's real. It's all real, you know. So Darrell, you lost your Skype.
I'm sorry.
He's still there. He's just not talking.
I'm here.
Oh, yeah.
Can you hear me?
Izabela, can you hear him?
Yes, I can hear you.
Can you hear
I
him?
seem to have lost my Skype screen. I may have to turn off Skype and come back. I'll ask.
Right, why don't you do that? You can just
okay.
join the call again, I think, if you're still got the call up. Oh, you may not
Very
be able to
good.
see it.
Be right back.
Okay, let me know in the chat if you can't get in. You still there, Izabela?
Yeah.
Okay. All right.
Holding Buddy not to walk around.
Oh, no. Don't do that. It's
not
fine
to
if he
stomp
does.
her. Okay.
It's fine. It's fine. Don't even worry about it. Okay, so we're going to Izabela's site. This is her astrophotography image processing site. And so this Universe Z, that's kind of cool. I think I actually went to it. I think I went to this on the Observatory computer and not the not my other one. So this is gonna be kind of slow. Isn't that weird? All right, just a minute. Let's go back to this here. Hold on. Wait a minute. How come this isn't working? Did I not go to it? Oh. Sorry guys. I thought I did this.
Can you hear me now?
Yeah, there you are.
Yes, we can hear you.
I don't know what happened there.
All right, Darrell. Well, that's fine. You're back.
Okay.
That's all that's important. You're back. Okay. Let's do this. I'm gonna bring up your Skype again here, Izabela. All right. Let's drag us over. And let's go put this link in again. There we go. And now let's go bring people to your website. While we're doing that, let's just make sure that, there we go, the monkey head's coming in, as you guys can see. All right, so while it's coming in, let's take a little detour to Izabela's world. Here's her site,
My world.
Yes, astrophotography image processing. She has home, broadband, narrowband, space art, journal, and contact. And the thing that's important here, I think, are her broadband and narrowband. And if you scroll down, she has examples: broadband, narrowband. The broadband she's calling what we do in Sky Tour West. And I understand the concept of broadband. What she means is we take all those narrowbands that we are capturing and we put them all together at once to make one image. We don't separate them out. Narrowband, on the other hand, what you see there, narrowband takes the hydrogen alpha and looks at it separately. The sulfur too looks at it separately, and the O3, the oxygen, the ionized oxygen. Okay, sulfur and hydrogen alpha are red, and the oxygen 3 are bluish green. And it looks at those separately with narrowband. We're actually taking all three of those and passing them all through at once to get a final image right up front. So that's the difference. That's what you're doing, correct, Izabela?
Correct, yeah.
Okay. So what would you like me to look at first?
Let's go to Broadband, because this is where the thing started.
All right.
I guess the seahorse on her.
Actually,
Cover.
sorry, excuse me.
Yeah.
Darrell?
Oh yeah,
Darrell?
I'm sorry. I was talking out loud. The front page there for broadband image, it looked like the seahorse, I think.
I think
Dark
not
Nebula?
the seahorse, dark horse or something with horse.
Oh, it could be that could be the
it was
dark
part
horse.
of it. The dark horse, exactly.
Okay.
But only part of it.
Yes, because it's
remember.
bigger.
Yeah.
She's right, because the dark horse is bigger.
I think that was one of the first images of the sky tour from Arizona. Yeah, from Arizona.
Well, I know that, yeah, Darrell, maybe we did that kind of before I was able to align the telescope at will. Remember when I couldn't align the telescope and I had to find a known object to align it? And now we just...
Right.
And now we just aim it at a point in the sky and say go, and it figures it out. I mean, we've done leaps and bounds here in the last 6 months. Let's go back in the broadband here.
Her remarking at the time that that image gave her fits to get it processed.
That's correct. I think she talked about the seahorse.
Mark, I suggest you scroll down to the bottom of the page to the Bubble Nebula.
Okay. This one?
Because it has a history, yeah.
Okay.
So this is the very first image, actually. Or was it the very first image that I processed? But that was the very first image I asked Mark to turn the telescope and look at it.
That's right.
And
I remember that night.
Yeah, I do. And although I don't remember, I have absolutely no memory about how I found Sky Tour. I remember how I asked for the Bubble Nebula. And
I remember that.
I was amazed that he just turned the telescope and showed it to me. And not only that, but the next night I think the next day he had it processed and put it in the group. And I was dumbfounded because who does this today in the world?
And that was well, you know what? And that's before we actually had the the live server, and so you had to wait for someone to give it to you rather than just go get it when you wanted it.
And it was gorgeous, absolutely gorgeous. And
it is,
right now
it?
I have it actually on the wall, right above the monitor which I'm looking at, and I have this image, and it is still there. I haven't removed it yet.
I'm glad. This is a beautiful nebula.
Yeah. So this is how the thing started, and I got hooked up. And
you got hooked like a fish.
Yep. For a bubble.
Yeah, for a bubble. And you blew bubbles.
But I have to tell here. I have to be very clear here that this image, actually, I asked Mark to send me images from him to practice on his images, and that was, I think, when no observatory was working. Arizona wasn't ready, and I think this one on the East Coast also wasn't.
This might have been in the interim when we were taking down east and putting up west.
Yeah. At that
taking
time.
down east to refurbish it we outgrew the eastern building, and we're in the middle of building the western building. We had some downtime in there. Yeah.
So it was looking like there would be a very long time without STLS, and so I wrote to Mark and twisted his hands to send me some images so I can practice. And that was one of them. And I have to tell that this is a copy of his image. This is absolutely a copy, probably worse. But it was very educational.
I think it's beautiful.
For me.
You did a great job. And then down below that one, this is the Eastern Telescope's view, and then this is the Western Telescope's view of the same region. And you can see this difference in the size of the field.
Yeah.
Yeah.
You can see it. But I like the first one too, the close-up.
Oh, me too. Me too.
Because it's very clear.
Yeah,
It's
and
clear
this one
here.
is before.
It's also, you cannot just enlarge it and you make them close up. But
We have to make a new one for you of this one because look at this is before we actually fixed the telescope's collimation
right.
error. So it looks good like this, but when you zoom in, it looks crappy, and so that was my fault. So we'll fix that. We'll fix that. You did a great job processing it though. Very nice.
Yeah.
And then of course.
Was this.
Yeah, and then you actually.
And this is, I have to say that if somebody is going to try to process images, my advice would be to research and to learn about what you are going to process, because it's very important to understand what is going on, what are the forces and what is the chemistry and what are all these things, because otherwise it's just a nonsense, just pretty pictures. But when you sit and learn about every element of here, every object, it suddenly becomes like one coherent, how you said it, becomes compact. And,
I know what you're saying.
Yeah.
I think what you're trying to say is that when you're analyzing and doing the image processing of these images, you have to understand what the chemistry is doing in effect, so that you'll know what type of colors you're shooting for and what type of result you should be looking for. Otherwise, you could make the entire view red thinking that's all hydrogen gas, but it might not be. You might be missing some illuminated dust, and that could be a problem. So I get I think that's where you're going, and this is all good.
Yeah, exactly. This is why I think that I like it. This is why I think I like your process images so much, because you really know what you're doing there. You know what to emphasize, and you know what to pull out and what is not so important. And for me, it's like this will look pretty, or this color will look pretty, but it doesn't make the picture. It doesn't make the whole picture. It's like to paint.
Yeah, I get you. I get that point. Now, you don't have the rosette in here yet.
I removed the rosette. If you scroll a little bit more, there is a rosette from the East
That's
Coast.
this here.
Yeah. And the Running Man and
the Running Man came out pretty, and then this guy here is the Elephant's Trunk from here.
Elephant's Trunk, I like it.
Yeah. This came out beautiful. This little segment looks gorgeous here.
Of course.
Yeah, and we took that from here with the East Coast Observatory. And so it was tough to tease that data out, especially because we had light pollution here. But you did a great job of doing that. Oh, look at it. Of course, remember this? That's the other night. The 37 cluster.
Yep.
A very funny cluster.
It is. Yeah. Very nice. And the Andromeda Galaxy, you did a really fine job on that.
Yep. I see the artist's eye.
Oh yeah, see, look, this is before collimation too.
Yeah,
see, now you have to do them all over again.
You know,
You have to do them all over again. Oh yeah, see, this is all before collimation. Now we have so much better data. You're gonna be very busy.
Right now I'm in such a period of making experiments. And,
yeah, you're gonna be very busy. That's wonderful. This is pretty too. This was the Caldwell 5. Yeah, look at it, Darrell. She did a fine job there. Look at that.
Actually,
that's a beautiful shot of Caldwell 5.
Kind of proud
That's really
with
nice.
this image, because
me too. I think you did a good job.
I read this. It's very difficult actually to shoot this image and to process it.
Yeah.
It's not very visible in the sky.
Yeah. It almost looks like a painting, like it's fake, because you brought out the colors of the stars very nicely and really darkened the background. This is beautiful. You know?
Yeah.
I don't
It's
remember.
fun.
I think we should.
that.
You were here for this. We should go look at Caldwell 5 now. We should go check it out so you can see.
They say
Very
it's
nice.
very challenging actually to find it and to shoot it. This is what I
Yeah.
read. I don't know.
Very nice
Oh,
work.
you're looking down on top of a beautiful galaxy. What's that, Darrell?
I said it's very nice work, Izabela.
Thank you, Darrell. Thank you very much. And
Sure.
you were so supportive. You know, it's. I sent Darrell some images because he doesn't have his Facebook, and I'm posting them on my page. So I sent Darrell a few images by email, and he was
Yep.
so supportive and so kind, and it's so helpful.
Well,
I don't know. There
Well,
is some magic here in this live stream.
Like I
Some
said,
magical
Well, that's-
people.
I see the artist's eye there.
Yeah,
It's
don't you though?
Very,
Don't you
very
though?
well done.
Yeah, it's a very pretty job rendering that. You know, and you know what? But like what you say, Isabel, that's what you get with everybody here. You know, everybody in here. When's the last time you saw like a foul comment or anything in the chat? Almost
No,
never.
No.
Never. And
Unless
you know, and
the moderators delete them all the time.
no, but
No,
but you would
that's-
see it. You would see comment deleted, and
No.
then I can read the comments. You know, and it's not a bad comment. It's a comment that the person either chose that not to do or whatever. You know. So-
It's,
Yeah.
it's this feeling of awe that you'd give us and excitement that it's contagious. You know, you change
Isn't
us.
it though? Isn't it
You
though?
mark.
Contagious.
I mean,
It's a contagion. It is. It's a contagion. It's a disease.
it's
And once you
contagious.
get it, as Darrell says, when he'll probably say this, once you get it, you have to just get bigger and bigger telescopes. You know.
Yeah.
That's the way
So
it
here
works.
this is Measure 33. The triangulum galaxy that you did is really pretty. The supernova remnants
And
down
I
here,
have a
gorgeous.
question
Yeah, go ahead.
about- My question is about this green area on the.
These,
Yeah. No,
these,
no,
like
no.
these green areas.
The green, they're not stars, but yeah, exactly where was. Yes, this one.
Okay.
No.
Right. Well,
We
that's
talked a
one
lot
of
about-
several. There's one there. There's one here. There's one there that's a little blown out. There's one there. There's one there. And there's one right here with detail in it. Okay. And there's another one over here with detail in it. Okay. There's
I
a lot
like
of them
this
in
one
here.
with the stars.
There's one there. So the question is, you want to know what those are?
I want to know
Those-
about the color is green again.
Yeah.
The last time.
You've seen that before. You've seen that
Yes.
before. Here. When we have photographed the Veil Nebula, you've seen that
Yeah.
color before. We're looking at what I think are supernova remnants in this galaxy. And probably because the green is probably more powerful than the reds. You look at the Veil Nebula, and you can see that the greens are far more powerful than the red hydrogen lines that you see. So across galaxies, along great distances, the green is going to look like the only color there is. But I'm sure if we zoomed in even more, we would find that there's, there still would be some red in here. In fact,
I'm
I can
sure
even
this-
see a little bit right there. I can see a little bit on the edge. So I think that there's probably more there than meets the eye. Very cool, though. This is a really nice job. What do you think, Darrell? Didn't you do a nice job on Measure 33?
Give me just a moment. I was looking up something.
Okay.
Absolutely, she did. Yes.
I
Yeah,
think this
so there
galaxy
it
is
is.
full of life.
Did you see 604
It looks
shows
full
up,
of life.
right? It does.
That's right, and-
The green areas are very green. They're very big and bright.
Yep. Here is NGG 604 right there that you were just saying, Darrell.
Yeah.
And then there's this beautiful little area right here.
Yeah, the green knots you've noted before over on the right-hand side, they really stand out nicely.
Yeah.
That's a great picture.
And you got this one down here. This, you can actually see the shape on this piece of this remnant really beautifully. You know, that's really pretty. Oh yeah, it's just gorgeous. Yeah, you see, did a fine job. So, and as far as where this is, where Izabela's site is, Izabela, how can they find you? Can you put your link in the chat so people can just do that, so people can find you? Because we're gonna go back to our stream here, and we'll come back to this maybe if you want to after. But let's go see what our monkey head's doing. We must have done like 50 stacks here. Okay, 30. Oh, that's pretty cool, Darrell.
The monkey head.
Yeah, just next to the jellyfish.
I see a monkey head, I guess.
I just don't. Let me handle the color here.
The horizontal line at the lower right is the monkey's mouth. The dark socket above that's his eye. And
this
little nose, yes. And maybe that's his ear over on the lower left.
Oh. Okay. All right.
Looks like a monkey head with a mohawk.
Has he been run over by a car? Because I almost can see that. Wow.
You don't see the monkey's mouth?
I see the mouth, yes. And the eye.
Yeah, that's the eye, and the mouth is the line below that. Does look like
this
he's
is
wearing
here.
a
That?
mohawk, yes.
Okay.
Mohawk haircut. That's his ear over on the left.
Actually, that looks like the right eye, the left eye, a smiley face, top of his head, and maybe a big ear over there, and maybe a right ear over there. And the mouth is right there, a smile. Maybe that? Boom. Oh wow, look at this. Look at this beautiful... We're at 100% now. Thank you, Izabela, for putting your link in the chat. That was very good. Thank you for also showing us a little bit about your site. And I want people to be able to go out to your site and see all the work you do.
I don't remember this. Have we looked at this before?
Yes, but not very often. Oh, this is really pretty, though.
Yes.
Izabela, you still with us?
Yes, I was mute.
Oh, okay. Okay. Thank you for putting your link in.
You're welcome.
All right.
Vera, are your red-headed monkeys called, you say lion monkeys, are they called lion tamarins or golden lion tamarins?
Vera will let you know in 20 seconds or so when she gets the message.
Okay, yeah, I just typed it in chat.
Okay.
Because that reminds me of something I saw many years ago.
Okay. Look at this.
That does remind me of it.
Look at this. This is just... I'm wondering if the focus is off a little bit.
That's really something.
Look at all these little stars. I feel like I need to refocus and start it over. Vera says could be. Yeah, I think the temperature has dropped some more, and I've got to just adjust the focus downward just a little bit more. So I'm going to do the unthinkable. I'm going to clear this stack. That's right, I did it. and get rid of my entire stack. I'm not saving it yet because I'm going to go back to my control panel, go here, and go down to 1 second again, and bring it up to that. And now I'm going to, let's see here. All right, and now let's bring up the focus.
That must be native to the Atlantic coastal forests of Brazil.
Is that what it was? Tamarins?
She could say better. I'll let me post a link here.
I was going to say marmoset myself too, and you said marmoset.
Yeah. I'm going to post a link.
All right.
I think that's it. I can tell the story if we have a minute.
Yeah, go ahead. I'm going to get this finished here. I think I got my adjustment done. And I think we're looking good, so go ahead.
Many years ago, a friend and I were touring the Denver Zoo. She had a flight out that day to fly back home. And we had a few hours to kill for her flight, so we went to the Denver Zoo and we're touring the zoo. And it was a busy day. It was a very nice day. Big crowd, and Denver being Denver, you get all sorts of people. Up in Boulder, Colorado, just northwest of Denver, there are Buddhist monasteries and stuff, you know, with real honest-to-goodness Asian Buddhists in there wearing their saffron robes in the whole 9 yards. And there was a group of them just ahead of us in the zoo that day, you know, walking. Everybody was walking the same direction and just strolling along from exhibit to exhibit. And there was a group of Buddhist monks wearing their golden robes right in front of us. And they entered the monkey house. And we followed them in there. And just a little ways inside the front door, over on the left, well, here was a big glass pane with an animal exhibit in it. And it was a golden lion tamarin sitting in a little naked tree branch. And it looked like a little old man wearing golden robes. And he was bald on top of his little head. And standing out in front of him was one of these Buddhist monks, Asian guy, older fella, wearing his saffron robes. And he was standing there. He had his elbow with the crook of the other arm, with his hand on his chin, with his chin on his hand, looking at this monkey. And this monkey was looking at the Buddhist monk. And they looked like mirror images of each other, okay? Like a little bitty little old man in a golden robe sitting in a tree, looking at a great big monkey in a golden robe standing outside, looking at each other.
Did you get a picture?
No, I wished I had. It was a monk contemplating a monkey contemplating a monk, okay? And it just hit me like a ton of bricks. You know, just the whole gestalt of the thing just popped out.
Oh, man.
A monkey contemplating a monk contemplating a monkey, or a monk contemplating a monkey contemplating a monk.
Yeah.
And that was just so zen, you know, the whole experience. And I've never forgot that. That was almost 40 years ago I saw that.
Great story.
No, and that'll never be recreated again.
Who knows?
Never
Maybe
to be
the monk
recreated
went
again.
Back, Maybe the monk went back to the monastery and told her about it, and they all came and looked at him again. But it just, I walked in and there was this tableau in front of me, and it just hit me right in the face. A monk contemplating a monkey contemplating a monk.
Wow.
The monkey looked a whole lot like that thing right there.
It's funny.
Same color.
That is neat. Wow.
All these moments will be lost in time, like tears in rain. Can you name that movie?
Blade Runner, Rutger Hauer, final scene.
Absolutely.
And he actually, believe it or not, he ad-libbed a good portion of that. Which is fascinating. Yeah, he ad-libbed a good portion of that amount. They gave him the script and he just did something else. He actually said other things, which is actually kind of cool.
That was, I think that was the first movie I ever saw him in. That made a huge impression on me.
Yeah, he's good. Yeah. Talked about Tannhauser Gate and all that stuff.
Yes.
Yeah. His name was Roy. Remember?
Yeah, Roy Batty.
Roy Batty. Are we going to Italy here? Is that what this is or something?
Mm-hmm.
No. That's not Italy. It's funny music. It's like, what? Oh, it's not a cha-cha, is it?
I don't hear the music.
You don't hear the music, you can't tell. Alright. Oh yeah, it's looking beautiful now. Look at that. Wow.
Like a flame.
Mm. Well, let's go to 100% on this now and see if the focus change was good. Oh, we got a little tiny bit of guiding slop there. Okay. We're not going to be able to use this. I must clear it. I will fix the guiding slop. I will fix the guide. Look, this is what you do in astronomy. Things sometimes don't work out and you just have to deal with it and say, So that's what we're doing. We're going to fix the guiding slop.
It takes a lot of patience to be an astronomer.
It does.
Once upon a time, Izabela, in the days of film, you'd go out and you would shoot pictures all night long, and you would be lucky if you got one good picture off that roll of film.
And you'd be overjoyed too, actually.
Yep.
You'd be overjoyed to just get one good picture. Yeah, you're right. All right, let's do this. Let me come down here.
And that little monkey had this look on his face like, that's the biggest damn golden lion tamarind or marmoset I ever saw. He just had this shocked look on his face, like.
That's funny. That's very funny. Okay, so now we do this. I'm going to set this now. This is the important one. I think this one's been overcompensating, so I'm changing the guider in the inside. As you can see now, the stars are round. We're getting instant gratification here.
So many colors of stars.
Yeah, and part of that is because of the fact that we're stacking right now. But I'm going to get rid of that. And then we'll go back to just...
Please.
Sure. I'll go back to this. So this will be our... There we go. So that's the 1 second exposures that we have there. Now I'll go back to the 35 second exposures, and we should be okay now. Alright. So here we go. Now let's go back into our stack, and this stack should show up pretty good. So we'll clear that. See, this, by the time we're done, Izabela, it'll be like noontime for you.
Yeah.
What's it, 8 o'clock now?
Already. It's, yeah, 10 to 8.
Yep.
And snowing.
Yeah, we just went through snow tonight. Alright, let's see what this shows us. We should see a good image here. Yeah, there we go. See, now we're looking good. Now, I'm going to leave it here because I want to show you guys. You see this noisiness, this graininess? This is the stuff that the stacking gets rid of. So when we stack, if you look at me here in the picture here, we take a picture and we take another picture. We align them to make them perfectly aligned. And we stack them on top of each other. We make an image sandwich like this. And the result is that we get rid of all this noise in between the stars and keep only the data we want. So watch this noise go away. Ready? Boom. Here it goes. Look at that. Look how much better the image improved with just a second stack. That's just stacking 2. So as we stack more and more and more, we see more and more of that data come out and more of the noise go away. I just think that's pretty cool. Alright, so now we'll do this. Look at that. That's the Menkib. Kato, where are you, my little friend? Kato? You remember that? Okay.
And if you flip it vertically, it looks like Santa Claus.
Oh. I guess so.
That's right.
Yeah.
So you achieved focus and started exposing again?
I did. I did indeed.
How many are we on?
If you look down the bottom here, it says we've stacked 5 right now. I'm really interested in drawing out this beautiful filamentary structure, this dark nebula in here. And the more we do, the more it looks like that's coming out. So, looks cool. Hey Pam Strutman, how are you? Good to see you. Thank you for coming out. Yeah. Yeah, that's why this nebula, it makes a good target, because you got this detail, plus you got this really cool reflection component right there.
Yes.
And you got one over here. You know, so you got, and then here's one here. There's a really a variety of things. So it's more like an emission reflection nebula, not just an emission nebula as I wrote, but it's okay. It's mostly emission.
Yeah.
You know? Let me just get all of it in play here. I'll just move it all in at 66% actually. There we go. Look how pretty this is.
It's like a monkey on fire.
It does, doesn't it? It sort of does look like that. You can't miss it. A monkey on fire. Eesh.
Can you go to Stellarium for just a moment?
Yes, I can. Okay.
Okay, and we're on the monkey.
Yeah. We're not far from the rosette.
Yeah, I see where we are. Very good.
Yeah.
Okay, thank you. No, I don't remember ever seeing this before.
Yeah. Well, see, we're very close to the rosette, and I'm waiting for the rosette to come up because I want to show people the rosette.
Sure.
You want to see a beautiful nebula? What?
Oh, there's Alhena to the upper left. That's Pollux's foot in Gemini.
That's right. Yeah. So we're up here right now. I believe. I don't think we're here. Okay, we're at the monkey head. We're here.
Yeah.
We're not way down there now, so we're right here at the moment. Okay. So yeah. Hey Prow, how you doing? Prow says, I don't see the monkey, but yes, the color is flame-like. Yeah, indeed it is. And that could just be the result of how we're processing on the fly here. So that's also possible. But I'd really like to make my way down and get a hold of the rosette before we close tonight.
Yeah.
But we have to wait for it to. It's kind of along that line. Look at this beautiful wall here. So how you read this, guys, is this way. All this dark here is a continuation into this structure. Think of this as like a hollowed out section of dark nebula that has a star cluster in it. Okay? And these stars are illuminating, causing the hydrogen gas to glow. And these stars also have bright, hot stellar winds, and they're pushing out, creating a cavity, an opening around them. So to some extent, they're clearing the inside, hollowing it out. And that's kind of what we're seeing here, isn't it? It's sort of like a little opening, a little cavity. You can almost see the three-dimensional view. Now, we don't know that for sure. This could be long and thin. It could be short and fat. But for the most part, these will be hollowing out these areas with their very, very heavy-duty, powerful radiation and stellar winds. So seeing that this is going on, you can imagine how at the edges of the dark nebula, some of it's going to kind of reach over, the fingers of dark are going to reach over into this space. And now the glow is coming from behind, because again, you're seeing this in 3 dimensions. So this may be forward, this may be up here, and that cluster may be back here in this nebula. That's kind of what this might be like. We don't know for sure, but if you look at the way the hydrogen is being ionized here, it's ionizing this edge, but not ionizing a whole lot of this edge. But there's dark nebula here, but you're still seeing that it's ionizing through that. This is a whole region, a whole vast region of ionized hydrogen all throughout here. I know you see that too, Darrell, but
Oh yeah, well, sure. I mean, that's a large dark nebula with, like you said, a hollow in it, and the star cluster inside is hollowing out that hollow and
that's right,
lighting it up. That's beautiful.
Causing it to glow. So if we back out, you can kind of see it. Yeah, you see it more now from here. You can see it out of the borders of this dark nebula, like here. Okay, there's a lot of dark dust in here, a lot of dark dust all throughout here. And this new star cluster in here, this star cluster has illuminated, the ultraviolet has caused this hydrogen to glow. And that's what we're seeing here. Really cool, I'd love to see that in 3 dimensions. Is it a cup? Is it like this shape? Is it like this shape? Is it like this shape? I mean, it's really interesting. You see that, Izabela?
Yes. Yes, I see it in the
Okay.
details.
Yeah.
When you process them and you go with the pen on all these details and you're thinking about
Yeah.
all of them, how this works, how this happens, is this toward us or it's facing the other way? It's very interesting.
Yeah. I'm going to
And
zoom
then you
in
cannot
now
forget
on
it
this.
anymore.
No, I know. You're right. I'm going to go to 125% because I want to zoom in on this part right here. So check this out. Look at the convolutions and the complexities in this dark nebula in here. Keep in mind that you see these little tiny streaks and these little tiny objects right here. These little tiny dots of black. These might be what are called Bach globules. I've told you the story before that I was fortunate enough to have a lecture by Bart Bach, who was the man who founded these things and had studied these all his life. And he was a big, tall man with long gray hair. It was actually kind of cool. You know, he wore it like sort of like a hippie, but he was an old guy, so it was really kind of weird. And we talked about the Bach globules. We talked about what he found, and I really just ate up his lectures. It was just so cool to listen to the man who had discovered these. You know, it's like meeting the guy who found Pluto. You know, Clyde Tombaugh. I met Clyde Tombaugh in Vermont at an astronomy conference, actually, and he and I sat on a grassy hill and started talking, and it was just incredible to hear these pioneers right from their mouths, the pioneers who found these things, because you get it straight when you talk to the pioneers. You know, when someone else interprets what the pioneer was maybe thinking, it doesn't come across correctly. It may not be exactly what you think. But so yeah, so this is beautiful in here.
Yeah, Tombaugh was a very down-to-earth fellow.
Very much so. Have you meet him? He was a great guy.
Yeah, he was a Kansas farm boy, if I remember right.
I don't actually remember, unfortunately.
I believe he was. I've seen old pictures of him where he was a farm boy in Kansas, I think, and he built his own telescope and used it, and he wrote, was it Lowell or somebody, impressed them suitably enough that they hired him. That was back in the days before you needed a college degree.
Yeah, right. Yeah, that's interesting.
Here we go again.
What?
Oh, look at him. Illinois.
Okay.
But he was a farm boy.
Okay.
I'll post the link if anybody wants to look. And they have the picture of him with his telescope out in the field on the farm.
Wow. Yeah. Darrell, can you and Izabela hold down the fort for about 2 minutes while I run to get something to drink?
Sure.
Sure.
Okay, I'll be right back, guys. We're still working on the Monkeyhead Nebula here. So let's hang in there. I will zoom out so you can see the monkey head as it is integrating before your eyes. I'll go to 40%. Just look at all those colors. No, 40% is too little. I want to go even more.
That is such a cool picture.
It's beautiful, Darrell.
I honestly don't remember ever looking at this before.
Yeah, it's funny you say that because it's possible that only I looked at this, but it's got so much going on. All right, I'll be right back. See, I'm just like I can easily sidetracked. I'll be right back.
So, Izabela, are you having a good time tonight?
Oh yes, perfect.
Or
Perfect
this morning,
time.
in your case?
Yeah. It's so different from being in the chat. Darrell, what do astronomers do on cloudy nights? do they do some calculations and some what they do? Because sometimes there's in the winter long cloudy nights.
Oh, professional astronomers or amateurs?
Amateurs, I guess they have jobs to go. Professionals.
I'm sure, they maybe they look at the data or, try to make it fit into their theories, or they do book work, or they've always got something to do, write their theses for their doctorate degrees, stuff like that.
Like drawing charts, sky charts, and...
what amateurs do sometimes, the first thing that came to mind was I remember something that was very popular 20 years or so ago. On a cloudy night, astronomy clubs, they'd get together and have star parties, so-called. Everybody would bring their telescopes, and everybody would look through them, and some of them were public events, so, we'd show people through the telescopes. But sometimes when it was cloudy and we had a star party going, well, out of boredom, they would break out what they called their light cannons. And what they used, a light cannon, like a cannon, like a piece of artillery, except it was light. Yeah. And really what they were was just camera flash units. And they would aim the camera flash down the focuser of the telescope and point the telescope at somebody over on the far end of the observing field and fire the camera flash. And it was like a tremendous spotlight, like huge spotlight. And it just, people are shooting their telescopes back and forth at each other with the camera flashes. And they called it light cannons.
So the astronomers know how to do fun too.
They're
not just,
things like that.
Or maybe just taking the telescope and driving south, where there are no clouds.
Sometimes that too, yeah.
Yeah.
If there's a thing called chasing sucker holes, where when it's mostly cloudy and there's just little areas of sky between the clouds, and somebody will always say, well, why don't you go look through that up there? And you're trying to keep up with it, and you're chasing the holes in the clouds, and never really looking at anything because you're trying to keep up with the holes in the clouds. And that's chasing sucker holes.
I remember this, chasing sucker holes. Let me write it down.
I can remember one night we had a impromptu viewing party at my place after work one night. This is when I worked up at the mine up in Leadville, Colorado. Highest city in the United States is over 10,200 feet elevation. And, well, the sky wasn't cooperating, and we wound up watching Tarzan movies all night.
That's cool. Hey, Darrell, I want to ask you something. Do you mind if I put, you sent me pictures of your fish and the clock and these things. Do you mind if I make a page on my website with your pictures, with your stuff?
I'd be honored.
Okay. Yeah. Oh, great. There is no better place to put them.
And I think she's the one that could probably do it best, Darrell.
I'll send you the whole file if you want all of them. I mean, they can be kind of repetitive. I showed you just a few.
I'll find a way to make them look good. I'll send you the link.
All right.
And you can send the link to your friends after that, instead of sending all these pictures.
Very good.
So we'll make them good home there.
Okay, I'd be honored. Thank you.
I've
tried to get Mark to show pictures of the fish before, and he never quite got the hint.
What?
Maybe no.
No, we looked at the fish head, and didn't they show you pictures? Didn't we show pictures of your sculpture with the fish head?
The one time we looked at it was just you, me, and Amanda, I think.
Oh.
Mark, I think Daisy and Zoe Amethyst have a good question for you.
Oh, I see. You know what? That's funny you mentioned that, guys. Okay. Daisy and Zoe Amethyst say, is it possible to do a 3D computer-generated image and view from different angles? So in other words, can we get any 3D representation of what these nebulae really are? That's something that, believe it or not, I'm looking into because I think these would make excellent pieces of art. Like they actually be able to look at a nebula, see it like it looks, and then move around it and see the illumination from all different angles. It wouldn't be exact, but it might be a really cool way to show a nebula like the Orion Nebula and then see it from a different angle.
It has been done. The Orion Nebula.
I mean, I know it's been done. Yes, but I'm talking about a physical piece of art that you put on your desk.
Oh.
That's right.
From what? What material?
Well, that's the thing. Okay, the material has to be translucent, and it has to have some rigid areas and some softer areas. So I have the technology to do both. So I'm trying to figure out ways to do it. It's been something on my mind for years.
Cloud Nebula?
Look at
Cloud
this.
laser?
No, actually, that's not effective enough because that doesn't give you any color. You need the colors.
Yeah.
But you're right. I mean that those intersecting interference pattern line lasers, those would work great for actually making a rendering of it, but as one bunch of like basically bubbles.
Yes.
Plastic melt bubbles.
Yes.
That is very tiny.
This will be so cool.
Yeah, I have. They were popular some years ago. I have one.
Where'd you go?
Dimensional, and well, here's how they got color and light in it. It just came on a colored base.
Yeah. Okay.
You know, it just had colored lights down in the base of this thing. You turn it on it's battery powered, and it. I think the colors spun too, if I remember right.
Yeah.
I have a fiber optic Christmas tree that's kind of like that. Just has a color wheel down in the base, you know, and a projector lamp.
Sure.
It'll look cool anyway. It was cheesy looking, but it's cool.
Well, you know, that's all right.
Daisy, there are videos out there from NASA may have done them. I forget who did them. The Orion Nebula in particular, though, they take you on a 3D tour flying through and around the nebula, and you look at it from all angles. And there are other
really pretty.
examples also.
Yeah, really pretty. I want to show you this. Look at this, guys. There's this area, one of these areas inside the nebula. This right here. This is really fascinating. We're looking at an area that actually has a very subtle stars that are inside the nebula. Okay, I'll go to 150% for this. Okay. These stars are deep inside this nebula, most likely. And they're showing as red because the starlight is being extinguished a little bit by this dark nebula in front of it. And so it's looking dark, looking redder. For the same reason the sunset looks red. So that's pretty cool. And it's neat how there's these very, very fine filaments that now show up that were not there earlier. We saw this one, but we did not see these. These are new. So these are going to come out beautifully in the processing. And I think somebody we know might be doing some processing on this and probably beat me to it. That would be you, Izabela. But
no, I don't.
She didn't follow.
Yeah.
That's okay. Okay, well, anyway, I paused the live stacking, And I am going to say this again because when in doubt, if you don't remember doing it, do it again. Nothing to lose, everything to gain. Okay, so now we'll save exactly a scene. All right, and now we're going to clear you, and away you go. And don't worry, we'll be back. And this will be up on the server in just a few minutes. So now we're going to go back to our 1 second mode, and we'll do the hyper process where I actually will show us the details going on up there, just like this. Okay, so there it is in live view, 1 second live view. And now let's hope and let's see if the next item up for bids is looking good right now. Right now we'll actually go down to this guy, hang out here for a moment. So we'll go to this.
I posted a link to one of the 3D Orion videos.
All right.
Take a look at that later, folks. Not right now, but later. It is a really cool video.
Very cool. OG put the posting up there as well. Thank you, OG.
Oh.
All right.
OG, you can't post a link if you're not a mod. Sorry.
Well, he put it up there. You could just cut it and paste it if you want to.
Yeah, I'll copy it and paste it.
Thanks, OG, though. Okay, let's do this now. Okay, now he's going to drop down.
OG, I think this link doesn't work. Let me see.
It doesn't?
I'm going to post ahead.
Okay. I found it.
Because there are actually a whole bunch of them at YouTube.
Okay.
And if you just follow this query, it will list all of them for you. There's a bunch of them there.
Okay.
Orion in 3D.
Where are we going?
Where we are. Well, I'm down near the 37 cluster.
Oh.
But there's also a nebula here, which I'm going to also attempt to grab while we're here. Yeah, right there.
Oh, Clyde Tombaugh. Well, he was born in Illinois, but his family moved to Burdett, Kansas in 1922. A hailstorm ruined his family's farm crops, and he couldn't go to college. So he built several telescopes with lenses and mirrors by himself.
Wow.
Amazing.
He is an amazing guy.
He sent drawings of Jupiter and Mars to the Lowell Observatory, which offered him a job. And that was back in the days when you didn't need a college education to be an astronomer.
I guess this was his goal, to have passion for something.
That's right. That's right. But you all know that I decided I was going to be an astronomer at age 9. And I didn't let that stop me. I became one. And in spite of my parents protesting, saying, why don't you get a job where you'll make money? So that was that.
All parents are like this.
I know, aren't they? Man. I'm trying to find our 37 cluster again. Oh, we got this really cool nebula right here. I'm going to take an image of that.
Maybe
I was looking at that.
Maybe they took
the
it
37...
down.
What?
Maybe they took it down because it wasn't on place. It's a funny...
No, maybe.
funny cluster, like it's not supposed to be there.
I know.
Oh, it is. It's been well known for years, long time.
Yeah.
Whoever found it first and said, golly, that looks like a 37.
That's right.
Actually, I read that if you read it in a different way, it also can be read like Y, X and Y, or something like this. Some people read it like letters, some people read it like number.
Oh, okay.
Depending on how strong is the telescope.
Yeah. Okay, we're going to do this a little longer, or actually for a little bit, just to see what this is. This is nothing that I recognize.
Yeah.
So we're going to do a 35-second exposure of this guy.
I thought you were on the Pac-Man when I first saw this.
Doesn't look like Pac-Man to me.
Oh, he's facing the wrong way for one thing. Or like a big lobster claw or something.
Yeah, so what we'll do is we will get rid of this hyper processing. We don't need it, and we'll go back to our stack and we'll clear this. So once you see this up on the server, you can explore the monkey head to your heart's content. Alright, so 35 seconds later now we will have our first shot of this nebula that I've never imaged before as far as I know. Of course, I'll tell you as soon as I see it if I've seen it before. Us astronomers were weird. Oh, here we go. Wow, look at that. That is so cool. It looks like a mini Rosette Nebula.
I know this one. Do I know
do?
everything in the universe already? About life?
I don't know,
and
you tell
meaning
me.
of life?
Don't you
What is
see
this
a
one?
kind of a critter, a monster or something? He's facing left.
Yeah,
His mouth is open.
it's
Mhm.
one.
The brightest part of the nebulosity at
Like
the
a
bottom
Muppet.
is his chin.
Mm-hmm. That's like Elmo. It's the Elmo Nebula.
Yeah, it's the Elmo Nebula.
That's pretty cool.
Yeah. So what is it? Do you know what this is, Izabela?
You wrote it like Rosetta-like nebula, but no, I don't think it has a name. It's Elmo.
Yeah. It's Elmo. It's the Elmo Nebula. Actually,
Yeah.
it's not the Rosette,
We
of course.
like
But
Rosetta.
we will... Yeah, the Rosette is where we're going to go hopefully next. Because now we have to come down a little bit. And then we're going to go to the Rosette, which is down here. But then we got this guy here, which is the beginning of some of the winter constellations. This is going to be gorgeous. Okay. It's like this is the... is it the Ghost Nebula or something like that? I can't remember.
Oh, the Ghost Nebula.
I don't think this is the Ghost. I'm not sure.
I've never seen it.
Okay, well, we'll look. But we're all trying to get to the Rosette. All roads lead to the Rosette. And we have Hubble's Variable Nebula and the Cone Nebula and the Christmas tree. But I want to get to the Rosette. If we can keep going south, we might be able to capture the Rosette along that edge. It looks good. And now we're up here still. We got a ways to go. We may not be able to... we're way up here. I don't know if we're going to be able to make it to the rosette without whacking the side of the... Not whacking, but having too much interference with the side. Let's take a look at this again. Look at that. Let's try and do some... Let's do some color balance. Okay, and now some little nearby process. Push a little bit. There we go. Wow. I don't know what this is, but it's really pretty.
So again, there are... Yeah.
I'm sorry. Go ahead, Izabela.
Again, I'm seeing these stars which are making like outline, like on the mouth, on the left side, right on the lip of Elmo.
Yes.
Right. Yes.
Yes.
Like outline
well,
of the
let's zoom
shape.
in and let's see if that's true or false. Let's see if they're actually... Let's see if they're lined up or not. Okay.
Yeah, there's a straight line along the lower left edge. There are some curved lines to the left, sort of like his left cheek, and they look like they're following the curve of the cloud.
You know, this could be tracks from past events in the universe.
Yeah, don't know. I just think that when you look at it, it's really not straight. I mean, it does curve. It's a gentle curve, and then it kind of gets all bobbly. But what I want you to notice, though, is right here.
Yes.
Those are stalks, pillars. Okay, like the pillars of creation. Okay, those are pillars as well, and these pillars are they're like evaporating pillars. And you've got dust in there and gas. And a hot star, maybe this one, or this one, or one of these that might be nearby, has enough radiation, ultraviolet radiation, that its stellar wind is evaporating and pushing down on this. But this part at the top is condensing, maybe to form a star. And the pillar, all right, is actually at the point where this object here is protecting the stuff down here from being evaporated away, because this is in the lee side, the downward side, from where it might be hitting. It's just a possibility, but
that reddest spot there. I'm sorry. Go ahead.
What? This here?
Yes, that looked almost disconnected from the rest of it.
It looks like it's slightly connected. It doesn't look disconnected as far as I can tell. We'll have to let more come in. We have to let more imagery come in. Let me do this. Let me do this guy right here. I'm gonna balance a little bit of the color, pull a little bit out, and do a little of this. Okay, let's see what we got. Oh. Let's go to 150% and look at this stock.
Yeah, see that?
Jury's still out. Yeah, jury's still out whether this is connected or not.
A couple more over to us left.
Yeah, that's what I'm saying, and I wonder if those are all connected and we just can't see that. It looks like they're connected, but I could be wrong.
Looks like lava lamp.
Yeah, right. A lava lamp is right. This is a universe lava lamp. This is the Lava Lamp Nebula.
That's really
great discoverers.
Yeah. And Izabela Melamed from Sofia Bulgaria discovers the Lava Lamp Nebula.
Yeah. I named
Let's
it.
go to auto here. Yeah.
Darrell discovered it.
That's really pretty.
It is. Stellarium
It's
doesn't
nice.
show or give a name to that?
No, no, it doesn't. I have it processed, but not on the website because the processing didn't look so sweet. It's actually much bigger.
Yeah. Well, I can capture it in my frame. So like if you can see, there it is. And again, there it is. Wowie.
Stellarium actually represented that pretty well.
Yeah. Well, that was a photo that someone took, for Stellarium.
Yeah.
Okay.
Interesting.
Yeah.
And okay, that's in Orion's right arm. I'll have to remember that. That's right in the crook of his arm, I think, his elbow.
Okay, because we're actually on our way down there.
Yeah.
It's where we're heading.
Can you zoom out for just a second?
A Stellarium.
A little more?
There's Betelgeuse.
Yes, that's his.
There's
Okay, that's his
Betelgeuse.
right arm. His right arm is
Yep.
up. That's around his elbow. Very good, thank you.
I wonder how... Alright. It might actually be easier to capture the Horsehead and the Flame than the Rosette. And even the Orion Nebula. Wow, this is really nice. It's a very nice nebula.
It is. I'm amazed that's not named. It is now.
It probably
Elmo
is.
or Lava Lamp.
The Elmo Nebula. Well,
I kinda-
even
I
Stellarium
kinda
has
see-
all these fancy names.
Yeah.
What do you see?
I kind of see Barney Rubble in there from the Flintstones.
Hey, Fred!
Yeah.
Yeah, hey, Barn. Hey, thanks, Fred. Hey, Dino. All right. We are at 19. We're going to do a 20 and then stop on this one and move on. It's all about getting the good stuff.
Where we're going now?
I'll let you think about it. Okay. I have a feeling we're going to go to the Horsehead Nebula.
Yes. I was secretly hoping for this.
Yeah. It's actually in a more viewable spot than the other Rosette at the moment. We have to wait for more. We have to wait for it to come up more. I'll leave this now, clear it. So that buffer stays. So that goes. Whoa. Okay. That was pretty. Okay.
Was that your dog, Mark, or Isabella's dog?
That wasn't a dog. That was a Skype thing.
That was Skype.
I thought I heard a dog bark.
No, that
it's not my.
was a Skype bleep.
My dog is behind me watching the nebulae.
Sounded like
TV.
a little yappy dog.
No.
But
Okay.
they lost Skype.
1-7, and now let's do this. Alright, so we have to go a little west, which is good because that gives us more room. Now we can go south.
I have a technical problem.
Which is what?
I lost Skype. The screen. I have the chat and the contacts on the left, but not the screen.
You just have to go back to your you just have to go back to the list of contacts and click on the conversation that says the chat between you, me, and Darrell.
Nothing happens. Maybe I have to restart. Okay. I'll be back in a minute.
Okay. Oops, went too far.
Oh, goodness. I'm going to have to
Oh
call
no,
it
it's
here.
starting.
I'm going to have to call it here directly.
Alright, well, we're going to do the Horsehead in a minute. I'm doing this. I think this is the, I can't remember the name of this nebula. How come I'm still awake and you're 2 hours behind me?
I don't know.
Okay. Alright, let's see. This is like the ghost or something. I can't remember. We're in Orion. So this will be cool. What just happened? Where'd that go? That's what I'm looking for. Oh yeah. Okay, so let's... Casper the Friendly Ghost Nebula, that's the one.
Oh,
You've seen that.
probably. I mean,
Barnard's
that has
Loop is all... What?
to be a stellarium then.
Maybe.
Hey, if I saw Barney Rubble, I guess somebody saw Casper the
Yeah, I
Friendly
guess.
Ghost.
Casper the Friendly Ghost, the Friendly Ghost, da 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 da.
Okay, I'm back.
Hello. Welcome back.
And
This
well.
is the Casper the Friendly Ghost Nebula.
Okay.
Whatever that means. That's the nebula. Okay, so let's go see what we can see. Darrell says he's getting tired and must leave. I do not know when this shall be, but it shall be probably within the next 10 minutes.
Darrell left?
But
Or not yet?
no,
No,
he's still
not
here.
yet.
Oh, okay. Darrell, come on, you cannot leave me here.
Oh,
I'm from Bulgaria.
it's almost 9 o'clock in the morning in Bulgaria.
10 o'clock
yeah,
almost now.
20 to 9. You're right.
Getting close to my bedtime. It's going on midnight here. 11:39 p.m. actually.
It doesn't happen every day that you have guests from Sofia. By the way, Mark, may I correct you about the pronunciation of Sofia? It's actually Sofia.
Okay, thank you. Sofia. Oh, that's nice to know. Oh, look at that. We have a satellite coming through too.
This is gorgeous. What?
Color. This is the Casper, the Friendly Ghost Nebula. I think the red is. I think this is part of Barnard's Loop right here.
I was going to say, yeah. The Stellarium view showed that.
Yeah. This is just beautiful.
The corner. That's interesting.
Yeah, let's see about doing a little bit of. Oh, it's got this stupid satellite that's going to be in it with the second one. Look, it's you know, the time out there is 11:40, and there's two satellites that are prominent in this view.
Yeah.
This line will go away over time. That one will take longer. Look at how beautiful this is. Holy crap. This is just nice. What do you think of that, guys? All of you out there. Hey, Roger Bridges. How are you? JSCO. What's happening, JSCO 77? Yay, Orion. Yeah, that's right.
Are you going to keep that or start over?
I should probably start over.
There's some neat detail down that.
Yeah.
Oh, this is beautiful.
Yeah, and this is going to go right through it, and that's going to go right through it. So it's like we have to come back to this because we have part of Barnard's Loop. I probably should move it over to the right so we can get more of the loop. This is the brown dust in this region. So it's just beautiful. It's just a gorgeous region. Kind of reminds you of the Ro-Ophiuchi complex. And let me zoom in a little bit on it. Actually, let me first color correct.
Remind me, please, what was Barnard Loop?
Barnard's Loop is it's actually a rather large, extensive swath of very nice ionized hydrogen that goes all the way up the left side of the constellation of Orion and up over the top almost. Look at this dust.
Yeah.
It's thought to be a supernova remnant.
Yeah.
If you trace it, it's like a semicircle on the left side of Orion. And if you move toward the center of the circle, it's close to the Orion Nebula. The thought is the supernova pass blew out an expanding shell of gas, sort of like the Veil, maybe, except it's more diffuse. That dark nebulosity is really something.
Yeah.
The clumps in it and stuff.
Yeah, we're gonna go to 100% here. Look at that. And this modeling goes away. Here comes that satellite that we don't like.
Is it like a bridge over it?
What do you mean?
Like this dark nebula over the blues? Is it like a bridge?
It's something
like
that's blocking what's behind it. So the dark nebula is here, and this bright nebula is back here. You know, so if you look at my, you can't see my image. Yeah, it's the dark nebula is in front of. Yeah. All right, let's get out of this. I can live with that bright satellite on the right as long as this one stays dim. Look at that dust, though, huh? Get this
It's very
beautiful.
beautiful.
This is brown dust in here. You're gonna have a field day, Izabela.
It's a
Field day.
Mistake.
Field day. You're gonna have a good time with this.
Oh yeah.
Mark, do you still have
This
that
is-
Orion image I sent you recently?
Which Orion image? I haven't
It
got rid of
was-
anything you sent.
It was a really deep exposure of the entire constellation, where you could see Bernard's Loop, and
Yes.
you could basically see everything in the nebula, in
Yeah, I
the
have that.
constellation.
I have that.
Might give people a good idea of what we mean by Bernard's Loop.
Yeah. Okay. God, this is really pretty. This is really looking nice.
It is.
Jeez. Wow. All right, let's do this. I'm going to find it right now, Darrell.
Oh, that's okay. It looks like a lot of trouble. We could probably just see it in the stellarium.
Yeah. Well, I keep going back. It's probably here somewhere. Going back too far, I think. Oh, man.
That's beautiful.
I just never realized how much beautiful dust was here.
Hmm.
I thought these satellites were going to ruin the image, and they haven't. So I can get rid of this, and that I won't even bother with. So we're at 14 stacked right now. And if I go to 100%, I'm hoping we won't see as much modeling. Yeah, see, we're not seeing the modeling, and the focus looks pretty good. We get a little modeling, but I can get rid of that. This is just so rich. And look at these stars. These stars are buried in this dark nebula, and they're trying to shine out from inside the dark nebula, and their light is reddened, like the sunset is reddened on the horizon because of the atmosphere. Well, the atmosphere of the dark nebula, basically, which is not air but just dust, is reddening this light as well. That's just incredible. Okay, so let's back out now. Wow. That's cool. That looks really pretty.
Yeah.
Mm-hmm. Very pretty.
I don't see Casper in there, but it's a very pretty image.
Yeah, I could care less about Casper. by monkeying with the colors here, you can actually see the dust become far more extensive. Look at that. Wow. I mean, that dust is obvious now, isn't it?
Yeah.
Wow. That is just outstanding. Wow. It's almost like I want to drop the blue, but then it makes it green. So you gotta drop the green a little bit. That's just crazy. Look at this. It's just,
Yeah.
there's so much going on there that you just never knew about. So much that you just never knew about. And I thought this was just gonna be a little, yeah. This is a nebula that I was just thought I was gonna just a little stop off while waiting for the others to rise. And next thing you know, I've got 20 stacked images. And they're gorgeous. So we'll stop here and come back to it. We'll have all season. We'll pause this and we'll save it. And then we'll save the stack. You see the stack is the FITS file, that sandwich of images is saved as a .fits file, which you can view with a FITS viewer, which is free online. Or you can just save or look at the PNG file, which is what you see exactly here, which is just the same stack, but just as a PNG file, so you can actually enjoy it and look at it. Wow, that's something. Gosh, I can't wait to come back to this extensively. Okay.
Too cool.
Something new.
Right, so now, yeah, that I had never looked at that one before with this telescope. That was the first. There's a few that are going to be firsts, I can tell you. We can see lots of things anew with fresh eyes. Don't forget, Izabela, we're going to be doing Thor's helmet.
Thor's helmet.
Season wears on. Yes, you did
Wolf
processing on
Rayet.
Thor's helmet. Yes, a Wolf Rayet star.
I'm beginning to frighten
Remember that?
myself.
Yeah, well, that's okay.
Yeah, if you look here on Stellarium, you can see it's faint, but that stripe of red running from above center down toward the bottom, that's all part
That's
of Barnard's Loop.
Mm-hmm. Yeah.
Yep.
I remember you mentioned it when you were talking about the Horsehead,
Mm-hmm.
right? Hmm?
Yeah.
Right. Or it's
we
my
were.
mistake.
No,
Yeah.
we're talking about the Horsehead, and I mentioned Barnard's Loop. Yes,
Mm-hmm.
I sure did. So let's. I don't want to do this. Get all that. Let's do this. Set the speed now to 1.5 degrees per second.
Jessica Stankovic
That's
in the
too
chat
much.
says, like something underwater, a diver. It's very beautiful.
Yeah, that's
It
right.
does
That's a
look.
good observation.
Mm-hmm.
Very good observation. Thank you. Okay. I think all of our Orion targets are up now to where we want to see them. All right. Okay, Izabela, be ready. Because this is gonna make you crazy. And everybody who hasn't seen the Flame Nebula, which is that one just to the left of the bright star, which is called Alnitak. And here you got this, which is a Horsehead.
How long of an exposure is that?
That's a 1 second shot right there.
Oh, okay.
Just merely 1 second. Remember that
Really?
days when you couldn't see the Horsehead without like a hour-long exposure or half-hour-long exposure?
Yeah. That'll really pop when you get some stacked.
Huh? Oh yeah. So let's let it settle down. Let's check the focus again, actually. I think we're okay, but I'm going to check anyway. I think we're good. You know, there's really no other place you can go to do this kind of stuff. I don't know that there's any other live observatories online. There are. I mean, there's people doing stuff, but this is this is a building established just for public outreach. You know? All right. Okay, let's do this. We'll do 45 seconds here. And 352 is good. And a few more seconds to get our guide star. And we should be good. And away we go. Live stack. Okay. The Horsehead Pet Heaven JSC 077 says. That's kind of a nice thing. I have a little girl, Dingo, who's gonna probably head there sometime soon.
Oh.
Yeah. And here we go. Pow! Haha! And
Wow.
1, 2, 3 satellites. I told you. This region is killer. It's near the equator, so you're going to see lots of satellites. Isn't that pretty, though?
It is.
Pretty is underestimation.
Yeah. Yeah,
Think those are geosynchronous.
They look too bright. I have a feeling they're going to be moving. But we'll find out in a second. They'd be on the equator.
Yes.
Oh, look at that. Yeah, see, the next exposure, this one moved out. Wow. We have to wait for this to go by, then we're going to do it over. Look, another one coming in from here.
Yep. They look almost evenly spaced.
Yeah. We got 1, 2, 3, 4. Any other pieces of crap coming through my field? As soon as this one leaves, I will be doing this over again. But isn't this gorgeous? You can almost see this whole region in 3D.
Yeah.
Yes.
Yeah, it's really good, man. Let me tell you, this is something else.
I've mentioned before the very large telescope at the European Southern Observatory down in Chile. There's a really cool video online of it. In one scene, they have a camera set up doing like a pan shot during a time exposure of showing like the 4 observatories in a row down there, the big ones, and you can see a whole procession of what I have to guess are geosynchronous satellites passing one by one over one of the domes. You can see like 5 or 6 of them in a line, and each one brightens up for a moment over the course of the time exposure. As you know, the sky rotates, and each one like passes in and out of whatever sun angle is that lights them up the most.
Mm-hmm.
It's really cool to see.
I mean, this is just beautiful. If we move up, you'll see what Darrell talks about at times. He says that the Flame Nebula looks like it's a gold color versus the red of the nebula for anywhere else in H2. I would say, though, that this part of the nebula is definitely the right red, but this might be material that's actually altered by possibly the black dust in the area. A thin sheet of this black dust.
Yeah, that's one of those pictures that just has it all.
Yeah.
Mm-hmm.
Blue reflection nebula and red emission and whatever the
white
gold
satellite
emission.
Trails. Yeah.
Look down at the very bottom. It looks like there's another dark blob, sort of like the Horsehead, farther down. Right down
here, you mean?
Yes.
Oh, right
down
there.
at the bottom.
On the edge.
Yes.
Right
And
there.
these 3 stars, they're like falling.
Yeah. Hi Chantel, how are you? Welcome. This is you're listening to not Amanda. This is Izabela Melamed from Sofia, Bulgaria.
Hey, Chantel.
She's been doing a lot of image processing of our stuff, and she's just a really awesome learner of this whole stuff, of all this topic. So we asked her to be a guest co-host with us tonight, and she's been showing us her website, which if you can put your website address in the chat again, that would be great, Isabel.
Yeah, sure.
Show people where they can find you. This music is really good to look at the nebula. Isn't it amazing this is live and coming through live?
Thank you, Chantal.
We're watching this satellite trail keep getting larger and larger as time goes on. It's just a bright satellite slowly drifting through. Yeah, it looks, Daisy and Zoe say, yeah, Flame is a perfect name. It looks like a tree on fire. It really does.
Yeah.
It really does.
Like nothing else.
So watch now this new trail here. Okay, how come we didn't get a new trail there? It stacked it. Alright, well maybe it went away so I can start over again. I hate to do this, but I have to. Okay. We want to get a perfect shot.
I think this
guys,
is a
we're
good
gonna
time for you to call it a night, Mark.
Okay,
It's
Darrell.
after midnight, and I'm turning into a pumpkin. So,
It's 2 o'clock
Izabela,
here.
it's
I'm
been
gonna
wonderful having you on tonight.
Darrell, it was all my pleasure. I just have no words to say how grateful I am.
Oh,
This was such a treat.
pleasure was
Amazing.
mine. Glad to have you
Nothing
here.
like this. Unforgettable night. Thank
Well,
you so
Good
much.
time still.
Yeah. Okay. Well, everybody, thanks for coming, and Mark, thanks for having me, and Izabela, thank you again for being here. Always a pleasure. And everybody, I wish you a good night. Okay.
Good night.
All right, Darrell. Thank you.
Okay,
We'll
take
talk
care.
to you soon.
Good night, Darrell.
Good night. Have fun.
Okay, bye-bye.
Bye.
Bye-bye.
Bye.
Well, you're still here, right, Izabela?
Yes, I'm here, staring
Okay.
at the screen.
Isn't that pretty?
Yeah,
Yeah.
speechless.
Oh, it's just beautiful.
This right angle there is killing me. It's what an arrangement of shapes and yes.
Wow. Yeah. So what do you guys think in chat? Do you think this is a beautiful area of the sky that we're taking images of? I'm going to guess that you like it.
Yeah. They're probably
This is
speechless
Sigma
like me.
Orionis. This is Sigma Orionis over here. This star is actually a sextuple star system. It's many, multiple stars, and this star here, the primary, is a very, very hot star. Eventually it'll go supernova, probably an O type star, and its ultraviolet light is responsible for causing this entire bank of hydrogen gas to glow. Alnatak here is responsible for some of these stuff, but there's also a star inside the flame which is responsible for making it glow, and I don't think we can see it. I'm not sure if it's Alnatak that's causing it. Might be. We got rid of the satellites. That's cool. Isn't this pretty? Yeah. Okay. Let me do a color balance here. It'll be subtle. Yeah. And now let me do a little bit of a processing. Make a little bit more. So I did a subtle color balance, and now you can see a very big difference in the whole scene. hard to believe this is happening in real time, isn't it?
Mm-hmm.
You know, I just don't know anyone that's doing this. I really don't. You're seeing full color images, just like the final processed images almost, right off the bat. And that is, I think, what sets Skytour Livestream apart. Really. Please do visit our sponsor, which is actually fxmodels.com. FX Models is a company that makes models of craters, 3D models of craters. FX Models is my company, but if you want to get a crater for Christmas, Tycho or Aristarchus, you can get those craters, 3D printed craters from us, hand painted by me, an artist and astronomer, and so it looks right. And you can get those if you order this week, you get them before Christmas. So just let me know. Visit the site www.fxmodels.com, and you can reach me at info@fxmodels.com if you want to talk to me about any of them. We can also offer any crater on the moon, almost, because these come from the curated data from the United States Geological Survey. I spoke to those guys; they're amazing people. Oh gosh, I'm running out of things to say because this is just too pretty.
So how you paint the craters? What kind of, with brush and paint and by hand? Everything.
I use special paints. I have lunar colors that I've mixed, special lunar colors, and they're meant to actually, and they will show us exactly what the moon looks like. There's multiple shades of gray on the moon, and there's also different colors on the moon. In that region of the two sets of craters, we have 3 different colors at Tycho and about 3 or 4 different colors at Aristarchus. And when I actually paint them, I paint the grays, okay, and it's actually with an airbrush. So it's very, very carefully metered air.
It must be very fine airbrush.
It is hard to do when you do it right, yeah. Thanks, JSCO. It does kind of look like a APOD picture, doesn't it? Okay, now what I'm going to do is zoom in, because we've taken 9 of these. Let's go to 75% on the Horsehead, which will be dead center. Boom, look at that. Wow. You can see this lighter area here that's on the Horsehead feature. That's really obvious, and you can see the gentle stuff coming off there. That is so cool. I mean, just the other night when I took a picture of the Horsehead myself, just for trying it out, I didn't see any of that. So this is pretty cool. I mean, it was easy to see, but yeah, I'm sorry, it's easier to see tonight than it was then. And then we have these beautiful reflection nebulae here. Okay, which are
the color is beautiful.
Just yeah, this dust is scattering. You know, this dust is scattering the light from the stars. It's really something. Look at that beautiful detail in that wall. And here's the other thing that Darrell said. Is that another Horsehead? Yeah, they're growing like warts.
So it is a diffuse nebula or dark nebula?
Both.
Both.
Yeah, it's a diffuse and dark nebula.
Things always get more complicated.
Look at that. Wow. This is pretty. The flame is fairly extensive, as you can see. This entire region is full of amazing beauty. So we have 12 of these here. We'll go to 15 on this, and then we will go to the, dare I try it, Orion Nebula.
Orion.
And the Running Man.
Okay, I'll be right back. I'm going to take a glass of water.
Excellent. Go for it.
Okay, in a second.
Isn't Izabela wonderful? She's really great. It's glad that I'm glad she could join us from Sofia. Wow. That's right. That's our Deep Sky Observatory. Let me try something. Let's see if this makes any difference right now. Because now what you'll notice is in this dark nebula here, you're gonna see like pillows. Alright, watch. Look down here, you actually see little like pillows, almost like pillows of I guess dust. You know, that's actually building up like almost like mammoth clouds that we see, and then they're in shadow here, not shadow, but they're not being ionized here by Sigma Orionis. This gas is being ionized, but it's all dark dust in here mixed with hydrogen. Look at that. Okay, well there's 15. I'll go to 16. I'll come back. Okay, now we have 16 of these. We'll pause this. We'll save it. Unbelievable.
How long it will
Let's
stay?
see what happens. Huh?
How long? How many months you can observe it? How long is the season for this nebula?
Well, this nebula will be out all winter.
Oh, winter. Okay.
Yeah. Yeah.
So no fear.
So no fear. Okay. So we're gonna clear this right now. And we're gonna get rid of it. I saved it. I hope. Okay. And now we're gonna come back down to 1 second. Do our hyper process. Look at that. Okay.
Mm-hmm.
And now, final object for the evening, just because I'd be a fool not to do it, is going to be the Orion Nebula. Which I think you'll appreciate.
I don't know much about the Orion Nebula. I was just thinking that, no, I don't know much about it. Of course, I know how it looks. I think I've purchased one, but from the Narrowband purchasing. but then I didn't know what I'm doing. Just, just putting together stuff and what happens. And now it'd be interesting.
Yeah.
And what I saw the last time you show it, it's going to be amazing.
Yeah.
Mm-hmm.
Yes, it will.
It's going to be something. David Schmidt calls it the ballerina with pink helmet.
The ballerina with pink helmet. Okay.
Mm-hmm.
Wow. I think I went too far. Let's go back down here. Yeah, I went a little too far. I was just going straight down from Alatak, and it's not the right way to go. That's okay. Okay. All right. Let's head west right now. All right, as we head west, look what we have coming in.
Mm-hmm. It's already gorgeous.
It's already gorgeous, and it's a 1-second test shot.
Mm-hmm.
It's not even the real shot. Okay, now I'm going to do something else. Okay, we're going to be right here, and I'm just going to move it up just a little bit. That means move the telescope down. Okay, one more blip. Now we're going to take some short exposures, very short exposures. We're going to try 100 milliseconds to see if we can get just the center of this nebula.
It's amazing how many details.
There it is. Okay, now I'm going to zoom in on that. And we'll see the trapezium, the 4 stars. So when you asked, well, you don't know much about it. Well, these are the 4 stars that power it. This is called the trapezium, and they ionize all the gas in this Orion Nebula. Very powerful.
Trapezium.
And if we increase the exposure a little bit, let's take the exposure to that's 100 milliseconds. Let's take it to 300 milliseconds. Right, and now you see that they're almost overexposing, but you see the center of the nebula.
Mm-hmm.
That's about the best we can do. I mean, we could do this maybe. It might be still show them as separate. Oops. I think I messed up there. Let's try this. Okay. 450 milliseconds actually. There we go. So let's zoom out. Go out to auto. Alright. Milliseconds. Oh yeah. Okay, we're gonna stack this. Why? Because what we're doing is we're getting just the inside of the nebula.
Ah.
Because we're gonna need to put it back in when we blow out the rest of the nebula.
I remember you mentioned this, that you take 2 different exposures.
Right. I'm gonna try this now again. Okay, I can live with that. See, what you're gonna do is this nebula is so bright, okay, so bright that we have to take. I mean, Jesus, that's beautiful, but it's not what we want.
I don't know if you can see the colors I can see here.
Oh yeah, I mean that's beautiful. And this is just a 1 second exposure. And we've got 2 satellites coming through. Just like that.
Well, there is nothing perfect.
Yeah. I know. Okay. Alrighty, well. Okay. I will pause this now. We've stacked 40 of those. And we'll save those. And then save exactly as seen. Okay, now we'll clear it. Get rid of it. Oh, thank you, Leslie. This is our last object, though. Oh, it's too bad you just got here. This is the last object. I'm sorry. Oh, okay. Let's see here.
I forget that I have a mic in front of me and this all kind of.
Okay. All right, took a snapshot, and that's good. Now let's do something crazy.
Crazy is good.
Hey, Lean. Yeah, we haven't seen Comet Leonard yet. It's going to be up around the middle of December in the evening sky. We'll be looking at it then. So hang out. And this weekend, an asteroid is buzzing by the Earth, very close to the Earth, and we're going to be watching it do it. So we'll be doing that on Saturday night too. All right, let's see here now. Okay. Let's do this. Let's do a crazy exposure of 45 seconds. Right here. Okay. Okay, this is going to show you some really interesting details in the Orion Nebula that you haven't seen, probably.
I don't know. Won't be there like a stitch between the two?
Not the way you blend them. Yeah, if you blend them right, they won't be. Okay, you ready for this?
Taking
See,
breath.
what is that? It's like that is just amazingly bright, right? So what we do is we actually come back here and we do a modification to the dark level, and we get that.
Oh yes.
Along with the satellites, of course.
This is something else.
Look at all this detail. Look at all this detail. This is not amazing. This is just crazy.
And with the running man above?
That's the running man, yeah. Now, there was a time when we used to take photos of nebulae, and this is what they look like to us. Okay? They would just be black and white images. But now we do have full color, and it's crazy good.
And then we will have infrared.
Yeah, and 3
I
satellites.
wonder
See?
how this will look infrared. Today I found one image of the winds on Jupiter in infrared.
Yeah.
It was so weird. Like 6 vortices, 6 or 9, I forgot.
Oh yeah.
So weird. It's like different world, like not from this world.
Yeah.
Like from Universe Z. There's somewhere.
Yeah, Universe
they
Z.
make them.
Your website, from your website.
My imaginary universe.
Now you see this? So here's the thing that's interesting about this too. Remember with the Horsehead I mentioned those pillows, like the pillows of dark nebula? Look at these. You have all these pillows of dark nebula here. Notice the color, it's brown. You know? This is a very dusty, dirty place in the universe. It's full of dust. A lot of it is carbon atoms, and then there's other atoms of materials, including molecules that were released in supernovae gone from the past. And JSCO 77 says, I never knew all the color was there. Yes, that's true. You don't really understand how much color there is in this nebula. But let's break it down, shall we? The light that you're seeing is the ionized gas. Okay? The red comes from hydrogen. The bluish green, this is from oxygen that's been ionized as well. So ionized oxygen makes the greenish blue. Ionized hydrogen makes the red. The blue stuff that we see as just up in here, let's move up. The blue that you see up here, this is dust that is actually scattering the light of these stars. Okay, and then there's some more going on in here, and you might say, well, look, that doesn't look like red hydrogen. It looks purple. What the heck is that? What you're seeing is the universe mixing a color palette for you. It is red, but it's embedded in this greenish blue glow. So what do you get when you mix red with blue? Purple. And that's why this looks sort of purple. And yes, that is the running man you're looking at right there. Cool. Wow, we're gonna be making a lot of inroads with this one moving forward. I just love this nebula. It's beautiful. Wow. So you're seeing oxygen and hydrogen here. It almost looks like you're looking underwater, as someone said before, like an ocean. And that's exactly what it looks like.
Mm-hmm.
Yep. Wow, look at that. I'd love to see that in 3D.
Yeah, you want to go from the other side, right?
Yes. Exactly.
Do they know what is on the other side?
Not really.
Or they just imagine it?
Yeah, they just try to figure it out, yeah, but don't know. Let's back out and look at the whole thing, shall we? Ta-da! Now you can see the connection here. There's a straight connection with other materials, and of course those satellites. Straight connection, all this material, all this dust. The Orion Nebula is like a blister on a gigantic dark nebula, right? That blister is a blister on the giant Orion molecular cloud complex. That's the OMCC, and it's just big, you know. We're gonna stack 10 and be done with this.
It's interesting how all this starts, like from a few atoms.
Yes.
It's amazing.
You're absolutely right. It is. Okay, we've got 10. So now we're gonna save this. And then we're gonna save the exactly as seen image.
Chris Horn is here.
Well, guys, I hope you enjoyed this foray with Skydro live stream tonight. We had a great time. It's 2:37 a.m. here, and it's time for me to actually get to bed. But look at this beautiful shot. That's beautiful, and I wish you the best for the night. These are all going to be up on the, look at yet another satellite. These are all going to be up on the OneDrive, public drive, in just a few minutes. So you have those to play with. Izabela, are you able to put up the link to the OneDrive?
Yes, I'm looking for the link.
Okay, thank you so much. And while you're doing that, I shall begin the close down procedure. Stunning, stunning, stunning. Okay.
Excuse me, I'm having a little problem with this.
No problem. Okay, so the first thing I'm going to do is I'm going to shut down our live link to the telescope with the planetarium program. Thank you, Leslie. Remember, the images are up on the server for you, Leslie. You can take them all of you can, and enjoy them. Okay. All right, and then this guy here. We're done with that. Okay, now I can take my focus system, which performed very well tonight, and disconnect and shut down. And now we can park the telescope. Finally. So you'll see the telescope move away from Orion. You'll watch Orion go zipping away, and the telescope will move to a predetermined park position, which is just what we needed to do. Out there in the building, 2,500 miles away from here. And then it says turn the scope off, and the telescope goes off.
Isn't it amazing that I'm sitting here in this side of the globe, you're sitting there on your side of the globe, the telescope is somewhere another place, and we are all looking at objects millions of light years away.
Isn't that crazy?
Mm-hmm.
Yeah.
It is crazy.
It does seem pretty odd. Yeah. It does seem pretty odd. In fact, the telescope is almost all the way around the world from you.
I have to check. It may be right below me, under my feet.
I don't know about that, but it's kind of cool, isn't it?
Yeah.
Yeah. So the last thing we do is I can shut this down. I'll disconnect the camera. Alright. And we cut down the camera, shut down him. Alright. And now let's actually now we're gonna do this. Just close the roof. Where'd it go? Alright. So here goes the roof now. So see, it's like 2,500 miles away from me, and another 6,000 miles away from you. The telescope's closing. I think that's pretty cool. And then this is gone. This guy is going to close. You still there?
Muted, and I'm talking and talking.
And wondering why nothing is being responded to.
Yeah, because JSCO77, thank you so much. You're so kind.
Vera, thank you.
Thank you. Thank you, Vera. Thank you, Vera.
That's very kind, Vera. Yeah, we don't forget the people that are kind to us. All of you that are visiting, those that donate to us, you guys are amazing. You know, we're still building up the telescopes. We actually want to add more things in our repertoire to all this for you. And we're going to be able to do it, hopefully thanks to you. So, in any case, you guys have a good night. I really enjoyed this time with you. And Izabela, thank you for coming on. It's been wonderful having you with us here on the Sky Tour live stream. And I know you had a good time.
Mark, I had the time of my life here. And it's an absolutely amazing gift. I don't know what to say. Thank you so much.
I think that you make you're a good fit with all of us here. You've always have been.
I don't know, feels like home indeed.
Yeah, it is. Yeah,
like-minded people and friends and.
That's right, like-minded people. But so you guys, what I'll do is tomorrow's what, Thursday? Or wait, today, that's today. Yes, today's Thursday. Tomorrow's Friday. So probably going to stream Saturday. The asteroid will be in the north. So actually pretty far away from the moon. So we'll be able to see the asteroid. And you'll actually be able to see it move, which is kind of cool. So, and hopefully we'll be able to capture it and get it all on camera for you. All right. So you guys have a good night, and I will see you on the flip side.
Good night,
and
everyone.
Izabela, I was gonna say, you can say good night to everybody, and we will talk.
Good night, everybody.
Izabela. And we'll talk Izabela in the next several days here anyway. So I want to thank you for coming on, and we'll talk to you all later.
Thank you.
All right?
Thank you.
Okay. Goodbye.
Goodbye. Good night.